Hi grade 12s, welcome to my channel. Let us have a look at this question paper from the Northern Cape. It was by request. I hope, Lucia, if I'm pronouncing your name correctly, that you're watching, and hopefully you will find what you are looking for. And of course, for all my audience, the people who continue to support this channel, I hope this is going to be to your liking as well. So let's have a look at this question paper quickly. Instructions, folks, cannot be overly emphasized. They need to be understood and to be carefully read with understanding and meaning, because a lot can go wrong. And remember, guys, we can use anything that is applicable, even if we have to apply calculus, optimization, and many other techniques from paper 1. We need to use them if we have to, all right? So math is not caged as we sometimes treat it. It is limitless in what we can do and where we can do that, all right? Even a topic ahead may be applied before, so keep an open mind. And of course, folks, issue of rounding off in this paper, we are to do 2 decimal places and no more or no less, all right? It's either it's there or it's not. Okay, so let's get to question 1 and take it nicely down all the way to its end. So question 1 reads, the scatter plot below shows the degrees, okay, of latitude of 10 cities in the northern hemisphere and their average high temperatures, okay, in degrees Fahrenheit. Okay, the least squares regression line is also shown, right? Now this latitude issue reminds me of geography when we talk of lines of longitude and of latitudes. The latitude ones are the horizontal ones, the longitude ones essentially the vertical ones. And remember, we also say in geography, the higher one goes, the colder it becomes. And essentially, we understand that if the latitude degrees increase, we should see a drop in the temperature. All right. So, and it looks exactly like that. We can see that with the increase in the degree of the latitude, we see a linear decrease in our temperatures. Okay. Quite truthful stuff in there. All right. So again, folks, if we look at it and perhaps want to comment about how are these variables that the average high temperature versus corresponding degree of latitude, we can clearly see that this is a linear correlation and it's negative, and some points actually fall on this line and others are close by. Perhaps this one is a bit further. We could consider it an outlier, but again we'd have to determine its position in relation to what we see before we can qualify it as such. All right, so this is essentially safely a strong negative linear correlation. To say very strong would be rather careless, because not all these points are really heavily populated around this line. So it's some points while others are not. So we may just safely say it's a strong positive linear correlation, so to speak. So guys, it helps to analyze and interpret what one sees, so that if we are to make a decision based on what we see, we at least play it safe, while we also not neglect being as accurate as possible. So 1.1 asks for us to use the scatter plot to describe the strength, okay, of the correlation between the latitude of a city and its average high temperature. And we need to motivate our answer, okay? Of course, we already have looked at that. So we'll just say this is a strong negative linear correlation. Right? And the reason for this is because the plots lie very close to the line of best fit. Okay, of course one can say the least squares regression line. We can say and some even fall on the line. Okay, so that's, I think, a fair justification for our observation. So we get a mark for stating what type of correlation it is, and of course providing a reasonable justification for what we are saying. So 1.2, we're told that the table below shows the data that was used to draw the scatter plot. And again, guys, it's very important to realize that we cannot use what is on this table to answer what is asked here. Okay, please do not make that error. What is asked here came before the table was provided. So cheating would be easy to see at the same time. Okay, so please try to comment based on what you have, and at the time we use only what is provided. What is given further down only applies lower down. Okay, so this is the table that we're given. Of course, guys, it is not labeled, but what we see here, that this is the x-axis and this is the y-axis, so we already have a clue. Sometimes we may be given this table without the scatter plot, so we may need to decide who decides what. What do we say in geography? The higher you go, the colder it becomes. It means the level of latitude then determines the temperature that is to be expected. So the independent variable here becomes the latitude, and the dependent variable becomes the average high temperature. Right, and we can see that with an increase in the latitude line, so to speak, the temperature somewhat linearly drops. Okay, can appreciate that. Right, we need to determine the equation of the least squares regression line. Easy. We know this is all calculator work. We need A, we need B, and then y cap or y accent is going to give us a final equation. So what do we do, guys? We go to mode, then we choose stat, and then we choose A plus bx, and our two-column table unfolds. And now what do? We fill it in. So please do it meticulously. So 5, 19, 34, 53, 22, 41, 60, 15, 60, 49. Okay, I see that I've got 10 entries, and ensure, folks, that this is all entered accurately. Take a moment here to do this properly, because rushing through this can result in some uncomfortable results there. Right, so 66, 87, 72, 56, 77, 64, 46, 89, 50, 59. Again, I've got 10 entries. I will hope that everything is good. So we press our AC button to store the data. Then we regress our data. Press shift, button number 1, we choose regression, and we choose A. So A comes up as 88, 26 to 2 decimal places. We repeat the process, shift 1, regression, we choose B. B gives us a minus 0.60 to 2 decimal places. Therefore, our equation is going to be 88.26 minus 0.60x. Okay, so that's our line of best fit, or the so-called the least squares regression line. Okay, easy 3 marks here, like that. So 1.3 says we need to predict an average high temperature for a city with a latitude of 28 degrees. Now 28 is within the domain here. So what is important is to notice that our smallest is between 0 and 10. Maximum is sitting at 60. So essentially, yes. I don't know what I was thinking, but I got a bit distracted in the process. Otherwise, folks, anything within the domain, we call it an interpolation, and therefore it is a fairly accurate prediction. So we know that we are not extrapolating. If we are to comment on its accuracy, we can say this is fairly accurate. All right. So we know that our y accent gives us 88.26 minus 0.6. Where we see x, we put 28. So let's sort it out. So I've got 88.26 minus 0.60 into 28. So we get a 71.46 degrees Fahrenheit. Okay, please folks, do not neglect the units of measurement when they are involved. Okay, never ever 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 forget that. Right, and the issue here is that we're told 2 decimal places, so we cannot have a 0.6. okay, we must include the extra digit, otherwise that representation is not according to the specification of our general instructions. Now write down the standard deviation of the average high temperature of the 10 cities. Now we still have the data nicely, so we're not going to waste our time. We go straight to shift number 1, but this time we don't choose regression, we choose the variance, which is VAR. Okay, the variance will give us the standard deviation and the mean, but this time we're looking at the standard deviation in terms of y. So there we just go and look for that. So I see it, and we get our answer. It comes up as 13.90. Again, remember this is degrees Fahrenheit. Okay, very important stuff. Again, calculator work here, just getting 1 mark. 1.5 says, determine the number of cities of which the average high temperature, say average high temperature, is greater than 1 standard deviation above the mean. Okay, so we need the mean in terms of y. So this is y bar. So let's get this thing started. So we go shift, but number 1, we choose the variance, then we choose y bar. What do we get? We get 6.6. Remember, 2 decimal places, so the extra digit is needed here. Again, what is this? This is degrees Fahrenheit. Okay. Now we know that 1 standard deviation above mean is going to be the mean itself plus the standard deviation in terms of y, which is going to be 66.60 plus what we got, 13.90. Okay, so this is plus 13.90. So we get 80.50 degrees Fahrenheit. Okay, right. Now we just look for any value that is above this value. So let's go look for it here on our table. So where is that? So what we will see is essentially this temperature as 87 is good. 70, no, not 70, but 89 is good, and there's nothing else. So there's just two cities. We can say, therefore, there are two cities whose average high temperature is greater than 1 standard deviation above mean. Okay, always make an attempt to answer as best as possible and as fully as possible. Okay, we don't like cryptic answers because it shows poor training and of course poor outcome in the student. Okay, you don't want to sell yourself short. Of course, we get a mark for getting our mean, we get a mark for determining this, and of course for the conclusion. Easy 11 marks for every student. I'm sure students got all these marks. We revised these in the channel. Again, it goes back to saying, folks, you could use this channel for a greater advantage no matter where you are in the country. Let's get to question 2. So question 2 is univariate data, but it is what we call grouped data. Okay, again, a grade 11 concept here. Right, it's usually put in question 1, but now swapped around just to give us a flavor of things. Okay, question 2 reads that 50 boys, how many? 50. Very important to pay particular attention to totals. Were weighed and their mass recorded to the nearest kilogram. The results are shown in the table below. Okay, good. So you can see that those who were between 60 and 65, there was just 2. Then 65 and 76, and it goes on. But now we will see that there's an unknown value here, as well as another unknown value there. So how will we determine those? We always think about it. Look, the frequencies, these folks are supposed to be 50 in total. So this means if we add all these numbers up, including the F, we should hit 50, right? So we can just take everything else from 50 and it will give us the value of F. Okay, very easy. So let's think about that for a second. So we're gonna say 50 minus the sum of all these numbers, 2 plus 6 plus 12 plus 14 plus 10. Nice and easy. It gives us 6. So this is 6. Okay, right. That's very easy. And again, we know that the addition of all these numbers essentially should give us the value of k, right? So what was that? We just say from that 50, we take away that 6. It gives us 44. So k should be 44. Very easy. I mean, there's many ways one can easily use the cumulative frequency and say, look, 34 plus what? 34 plus 10. It goes this way, We add that 10 to give us that. So 34 plus 10 is 44. Already cool. Then if this is 50, we're going to say 50 minus what is this 44. Okay. So there's many ways of looking at this. But guys, there's no excuse for not knowing how to do this properly. So let's get our job done as best as we can. First of all, we need to write down. See, we don't need to show how we got it. Just write down the values of K and F. So F is essentially 6. What is it? Boys. It's a frequency. Of course, may be necessary, may not, but because the value of f is just a number, right? So yeah, and then k, we saw that it's going to come up as 44, again boys, but at the same time k, they represent a cumulative frequency, so we may not really care a lot about saying boys or not. But again, guys, when something is a bit shaky in your brain, just put it inside brackets to protect yourself from trouble, especially if it becomes a necessity. We never know what examiners are going to say are the points to consider, especially when an answer is easy, guys. One needs to be very careful because those easy answers have very unforgiving restrictions. Any small little carelessness there results in a loss of a very easy mark otherwise. And it's quite an embarrassing situation because you may feel your teacher hates you, or even the person who marked your script didn't really feel you, but it's not because of that, but it's because of how you behave. Remember, we have been given instructions. Now, instructions are not options, they're not guidelines. These are not options for you. These are strict rules to adhere to at all times, unless, of course, a different scenario is being presented and a different destination is proposed. Right, let's finish this thing, folks. We are asked to draw an ogive, or the so-called cumulative frequency graph, for the data on the grid provided in the answer book. Now, I do not have the answer book here, so I'm going to have to convert my stuff here, the grade, into one that can help us. Okay, here we go. But folks, please be able to use the grid provided, because that grid is the one that gives the best answers. This one may not, but if we come close, then it's good enough. Okay, it usually just works if we work our scale properly. Okay, so folks, we know that our cumulative frequency graph, or an ogive, is essentially what it is. So we can just say this is the ogive of the data. We must always present a topic or the heading for the graph. Any graph that is just without a topic is no graph for us to consider. Okay, I'm saying us, pretending to be a marker or something. Right, on the y-axis, what do we see, guys? We're going to plot our cumulative frequency numbers. So they range from 2 to 50. So we can just go perhaps in tens if we wish, and say this is going to be 10. But I mean, it goes to 50. It's not so bad. Can actually go in fives, but let's just go in tens. 20, 30, 40, 50. It looks like it's going to be too small, eh? We want it to be nicely spaced as well, so that we can appreciate it nicely. Okay, so perhaps let's make it a bit longer. Okay, so we can say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. So it's not bad. Of course, guys, these are the things in question 1 that take a bit of time away. And there's nothing we can do about it, okay? We just have to do our best. Okay. So, again, on the x-axis, we don't necessarily have to start at exactly, 0 and all that. We can actually just start on the lower limit of the first class. So we can say here on the x-axis, we're starting at 60, but on the y-axis, we're starting at 0, right? So we say 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Okay, we know that this is the cumulative frequency. Okay, CF. And here we've got the mass in kilograms. Right, easy. So now what I'm going to write on the x-axis here. So if we say 60, perhaps we say 65, 70, 75, 80, 85, 90. Okay, it ends up at 90. Perhaps we can just push it to 100. Looks like our stuff is a bit longer. Can make it reasonably short. Okay, so this is essentially what we need, folks, and we just need to get our stuff sorted. Okay, so what I'm going to do, I'm going to create a vertical line because it will help me fill in my stuff. Remember, when we do the cumulative frequency graph, we take the upper limits of every class and plot it against the corresponding cumulative frequency, right? Right. So that's what we're going to do. And of course, to ground our graph, we ground it on the lower limit of the first class. So obviously, the ground is going to be here. And then we move our graph in. So what are we looking for now? 65 and 2. So 65 is over here. And we want 2. Remember I said this is 5, so 2 is perhaps over here. All right, we move. 70. 70 here must give us 8. So this is 10, so it's just before 10 somewhat. Okay, we move on. We want 75. 75 goes with 12. No. 75 goes with 20. Right? So there. Nice and easy. And we move on. 80 goes with 34. Okay, so this is 30, 35, 34 is just before that. Right. We move on to 85. Now 85 went with 44, so 44 is just before 45. Okay. And of course 90 is our last plot. It will go with the grand total of 50. All right, so that's what we have. Then we can get rid of our vertical line. All right, so let's just draw the graph. Okay guys, so there's our ogive. Does somewhat curve because it should be S-shaped, you see, but again, my grid is probably not the best to use to give that shape nicely. But we've got it done. So of course guys, if everything is good, we get our 3 marks. Right, so we've got 2.3. Okay, now 2.3 asks us to use the graph to determine the median mass. Of course, we'll take half of our cumulative frequency. If we've got 50, so it's going to be 25. So we take it to the graph, and from the graph, we drop it down. Okay, if we look there, what should this be? Okay, this is 70, 75, perhaps 76, 77, you know, perhaps 77 we can say. So this is approximately 77 kgs. So this gives us our Q2 value. So we can just say our median mass can write Q2 here is going to be approximately 77 kilograms. Okay, so this is good. We get our 2 marks. All right, so that's simply what we do, guys. We know that this is going to be 25, halfway of our total number of cumulative frequencies that we have here. Not necessarily the total, but the last one. Great, or we can say the total frequencies. So 2.4. We need to find the percentage of the boys who weighed 83 kilograms or more. So we go and estimate where is 83 here. Okay, let's get ourselves again a nice vertical line. So we go and estimate where is 83. Remember, this is 85 over here. So this should be, move. I would estimate 83 to be over there. Maybe too close, yeah. Yeah, but if we say 1, 2, that should be 3. It should be okay. And of course, we just have to intersect our graph. So we need another horizontal line. What are you doing? Stop doing things. So from where this line cuts the graph, it goes across like that. Okay, that's about it. So we can just clean up now. We just clean up the extras that we don't need. So we know that this is where we estimate 83. Of course, I could be a bit far off. It doesn't really matter though. So again, we can see that this is around 41. Okay. So we can clearly see that that's 41. And of course, it's going to go all the way to 100. Not 100, but to 90. So we need to consider all these folks up in here, because that would be the folks that have, an area that is greater than, that is 83 or more. Okay, so what do we say now? We can just say the percentage of boys is going to be 50 minus that 41, all divided by how many are these guys? They are 50. Multiply by 100%. So let's get it done. So 50 minus 41 is 9 divided by 50 gives us 18. Times that by 100, it gives us 18%. Okay. Of course, folks, here we may be given a range of values that we may have to consider. At the end of the day, if our job is done, it is done. Okay, it is done. So this is perhaps the last 2 marks. Again, this was an easy 9 marks to score, folks. Nothing major. All right, so let's move back to our normal template and move on. Question 3. Now this is the start of some big stuff, okay? Start of some big things. The nice things. Now this is where marks get scored as well as get lost. Anyway, let's see. So what we've got here is a diagram where A, no coordinates given. So this means we need to consider how we would find the coordinates of A, if at all possible. B, with those coordinates, essentially a point in the third quadrant. C, a point in the second quadrant, are vertices of triangle ABC. So where's ABC? There is ABC. Okay, so that's the one. Okay, good. Now CA produced. Now once we hear that word CA produced, it means this is all a straight line. Okay, it just means this is a straight line all the way. Right, to cut the x-axis at G, of course we know that we also need to consider how we're going to find those coordinates, if at all possible, and of course if at all necessary. Now F is a point on the y-axis, and we can see that there is F. Again, point F is such that there's a 0 on the x and then some y value. We need to think about how to find those coordinates as well. Okay, and E is a point in the first quadrant, so nicely shown, which is a point on CA such that FE is parallel to BA. Okay, cool. So in this triangle, if we think about it, in this triangle, we may have to think about using similarity, you know, if at all necessary again. So these are things that, as we read the statements, we just get our minds to be in the mood to perform our mathematical gymnastics to perfection. Okay, so another issue is to suggest that if we've got the gradient of AB, we essentially have the gradient of EF. Parallel lines have equal gradients. Okay, line AB passes through the origin. So you see, this is another point on AB. So this means we can actually find the gradient of this line by using the origin and B. As long as we don't have A, we need another point. Right, the equation of CG is this one. So again, this is indicated here. So it's not a problem. So we don't really worry about a lot. This means we can find the coordinates of G, because we just make y 0, so x becomes 15. So this indirectly gives us the x coordinate of G, and in fact, that full point. So we can see, okay, we've got enough info here. So what would we do to find the coordinates of A? If we look at A here, A suggests that what we would need to find those coordinates would perhaps be to find the gradient of this line, right? Line AB. In fact, its equation, and then use the equation of CG, solve simultaneously. We have point A. So if we ever need point A, it's going to drive us through the process of simultaneous equations. So we can handle that, okay? Right. And then I think we've got what we need. And at the same time, if we need point F, we have the gradient of this line AB. We can find it. It would be equal to the gradient of essentially that line. So we can even use the gradient because we know the x coordinate is 0. So what would be the y? We can just use the gradient straight up. We don't need to look for the equation. But if we need, we can. It would give us that the y-intercept is essentially going to be the y value at f. So we can essentially do everything that we are given here nicely without any fear. So if that's the case, we can challenge those questions head on. We need to calculate the gradient of AB. Very easy. MAB is going to be y at O minus y at B divided by x at O minus x at B. Of course, one may be wondering, we were asked about AB, so why are we including O? We can say here B, O, and A, just to be complete, are collinear points. Is it double L? Don't remember. Collinear, not sure. So these are collinear points. So collinear points are such that the gradient between any two is the same. So it helps again to display that you're not doing this out of ignorance or just following some procedure. It literally displays that the student actually has an understanding. How did I select that? Goodness, this thing. I don't remember selecting that, but it's now all of a sudden on the pink one. Anyway, this is 0 plus 1 divided by 0 minus 2 is going to be plus 2. So this is essentially a half. Nice and easy. I mean, it's fairly gentle. Positive gradient, we can accept it as true. Easy grade 10 question otherwise. So this is 3.2. We need to prove that essentially CB is perpendicular to BA. Okay, so what we can do, we can multiply the two gradients, and if the product is minus 1, we can say, okay, those two are perpendicular. All right, so we can say MCB times MAB is going to be, can say y at B minus y at C over x at B minus x at C times the gradient of AB. We want to see y at B is minus 1, minus 7, divided by x at B, it's minus 2, plus 6. This one, we got a half. So what do we see there? This is minus 8 divided by 4. It becomes minus 2. This is equal to minus 1. We can say, therefore, CB is not parallel but perpendicular to BA. Again, we can say MAB times MCB is minus 1. Okay, nice and easy. So essentially, how many marks? 3 here. So very important here, guys, to say this substitution, this determination, of course, a conclusion with a valid reason, I suppose, is it 3 marks, but anyone can look at it however that makes sense. As long as the proper procedures are followed and with reasonable outcomes, we can accept the results. Right, so we know that we've got 90 degrees now here. Okay. Right. We need to determine the equation of FE in the form y equals mx plus c. Easy. We know that the gradient of FE is equal to the gradient of AB. Right, which is going to be equal to a half. Reason, we know that it is given that essentially FE is parallel, not FG, but FE is parallel to BA. Good. So we can say then the vector FE is y equals a half of x plus c. Now we use point E because we were given that point. This is 3 and 4, just such that 4 equals a half of 3 plus c. Therefore c is, so this is going to be 3 halves taken from 4. Okay, 4 minus 3 halves. Oops. Go back to computing mode. So we're saying 4 minus 3 halves. What is it going to be? 5 halves. So we can make a conclusion that that equation is a half of x plus 5 over 2. Okay, we can accept this. 5 over 2 is essentially 2, 5. That's less than 4 because that's the point below point E. So if it makes sense, folks, in terms of what we have on our Cartesian plane, we shouldn't worry. But again, we need to be as meticulous as possible. So this is key. That substitution is key in the final answer. Alright, so let's look at 3.4. 3.4 says we need to calculate the size of OFE. Where is that? OFE. So we need this angle. Okay? So how will we find that angle? Okay, that angle is fairly easy. We can see that that angle actually corresponds with this angle right here. But what is that angle made up of? 90 degrees of the origin and the x-axis, as well as this angle of inclination of essentially AB. Maybe we can call it theta. See? So this means it's going to be just the addition of those two. 90 plus theta will give us that angle. And other students who like, they can just draw a horizontal line here and look for the angle of inclination of FE and add 90 degrees. But I think it's nicer if we use corresponding angles, just to show that we are very much aware of what we are supposed to do. So we will say, firstly, let the angle of inclination of AB be theta. Remember, guys, we can't just show up with a theta that nobody knows its origins. So we need to state everything. As we annotate, we state to guide the marker into what we are thinking. All right. So what are we going to be doing there? We're going to be such that we want to know that what is that size of that angle. We also want to know, we know that the tangent of our theta is going to be equal to the gradient of AB. So this means the tangent of theta is a half. So therefore our theta is going to be the arctan of 0,5. What is it? So shift tan of 0,5 is 26,5. We can round off to the, to two decimal places, so it's 57 degrees. Okay, easy. So now that we have this, because we knew that we needed theta, we can say then we understand that OFE is essentially equal to okay, what are we gonna say? Yikes, we don't have a point on the y-axis now to use. I wish I did have, but we can just easily say 90 degrees plus theta. because we know that the x-axis and the y-axis meet at right angles. So we can just say these are corresponding angles with FE parallel to BA. Right. So this implies that OFE is going to be 90 degrees plus 26,57 degrees. Therefore, OFE equals, so this is 90 plus 26,57. Right. So this is 116,57 degrees. Nice and easy. All right, folks, we can see that's an obtuse angle. So there's no way we are wrong here. So very easy 3 marks, but one that needs some careful consideration before it is executed. Obviously, folks, we need to get a mark for this. And we get a mark for that statement and reason in the final answer, okay? So again, ignorance, guys, does not pay. Let me tell you what are the benefits of showing all the workings like this. Say in the event that your center or school is under investigation for copying. As it happens in this land of ours, corruption happens at all levels of our society. Now let's say there's an investigation into those students who wrote in that center. Students, I can assure you, if you are this elaborate, you show and display understanding of your work and also portray that it has been you who was writing here and writing with understanding, because remember, the memos don't always do things like this. So chances are it's very unlikely to show up exactly with the way the memo has approached questions, even if it is a similar way, but some little extras on your part can defend you so that your marks don't get caught in the mix, okay? So if everyone is under investigation, you will probably not be the one included, because you already portray that this is you working your stuff out from your understanding. So please, guys, don't take things for granted. I know certain things are easily overlooked, but they have a long way when trouble hits, okay? Right, so this was 3.4.1. So let's deal with 3.4.2. We need to find the area of the quadrilateral OFEG. Okay, so how will we do that quadrilateral? Well, there's a few things, that we can do. Of course, one would want to lean on saying this is probably one of those high-ish, grade-ish type of questions, but it's not really that bad if one has been following what needs to be done. Now, there's a few things we can do here, right? This quadrilateral is made up of a trapezium, right? It's made up of a trapezium. Let me just show where is the trapezium. This is a trapezium, okay? But the challenge here would be we don't know what is the perpendicular distance between those parallel lines. So that technique would not really serve us any good, okay? So we want to abandon that. But we've got other techniques that we can use. Do we know the coordinates of A? The answer is no, because we could split our quadrilateral like that into this triangle over there and this trapezium underneath. But again, yes, we can actually do it, but it would force us to find the x coordinated A, which we don't have, and there hasn't been a question about it, so we don't want to run into trouble with that. So what is the best plan? The best plan, folks, would be, but I think we cannot avoid, we certainly cannot avoid the We cannot avoid f 100%, even if we like. For us to succeed here, we definitely need that point f. But now we've determined the equation above, so this kind of gives us a better way. Because once we have f, what I would propose is that we split our business in this fashion. I still want my theta to come up here. If we split our business like that, look what we end up with. We end up with a right-angled triangle on this side. And essentially a trapezium. Let me show you these structures. So essentially, guys, we end up with this nice triangle. See, what is nice is that we know the x-coordinate at E. So this means we would know what this distance is. Okay? We would know what that distance is. And once we have this distance, what is nice is that it would be the x value at E minus the x value at G. Again, this says to us we cannot avoid G, but the good thing is that we have enough information. So we need 2 points here, G and F, to succeed. I don't see any other way we can go about business here without any struggle. But I think that split would be very good, because if we've got F, so we already have that side OF, and XE, if we will, this is just 4 units, so we will have it. What is the distance between them is the x coordinated E. So this is perfect for business. So again, guys, these are questions that unfortunately cannot be done without a bit of consideration. And of course, a back seat to plan how to go about business. So we need the coordinates of F. We can say F is such that we take that equation we got above, is such that 0 is equal to a half of x plus 5/2, isn't it? That's what we got. In fact, why do I even bother? I mean, F, we've got it. The constant, we don't justify this. Or at least we can just write F is the point 0 is to 5/2. Okay? Perhaps we may want to say this is the y-intercept of FE. That vector. Okay? So we don't need to justify that. We can say likewise, we know that G is the point such that 3 into 0 plus x is equal to 15. Therefore, our x is 15. Therefore, G is the point 15 and 0. We needed those points. Again, a student who realizes that there's a lot for me to do here can easily just write the coordinates of G are these and furnish a justification. That's the x-intercept of that line. But again, to show a calculation is not that helpful either, because the x-intercept needs to be uncovered rather than the y-intercept, which is obvious. Right, so we can say then area. Okay, maybe let's say then let's say let we've got A, B, C, E, F, G, maybe let's say H. Let's just say H, let H be a point directly, of course we're choosing this out of convenience, be a point directly below E such that H is 0, such that H is 3 and 0. Okay, all right. So if we say that, what can we say? We can easily go for the kill now. Say area of OFEG is going to be equal to area of basically OFEH plus area of triangle HEG. HEG. You see guys, with a nice plan, everything falls into place. So what is this? This is going to be half. It's a trapezium, right? Because this line is parallel to the y-axis. So it's going to be half sum of the parallel sides. We can write OF plus HE times the perpendicular distance between them. It's going to be OH plus. This is half the base. Is going to be HG times the perpendicular height, which is HE. Nice and easy, folks. So we've got a half into OF. It's just the y value at F. So this is 5/2. Plus HE is just the y value at E. So this is 4. OH is the x value at E, which is 3. Can you see how nice this becomes? Once a nice plane is put, easy. Now this HG is going to be 15 minus 3. You can write it. It's a horizontal distance between those 2 points multiplied by HE, which is just the y value at E. At this point, we go for the final answer, but making sure that everything is right. So 0,5 into 5/2 plus 4 times 3 plus 0,5 into 15 minus 3 into 4. So the answer that I get, guys, is 33,75. We can say square units. Right, we don't forget to write the unit of measurement when we do a measurement type of a calculation. Okay. Right, so as you can see, guys, the best plan is what gives us what we need. But again, it doesn't mean it has to be this way only. As I showed you guys, there are other options, but those options will cause a student to work a bit more. So, yeah, but all I can tell you is that whatever way one can think about, these coordinates of G need to be shown. The coordinates of F would need to be shown. Perhaps we may even have to consider the y-intercept of this line CG. But again, it's given. It's going to be 15 divided by 3, which is 5. So that's what we can think about. But anyway, we move on, guys. So this is good. This is good. 2 marks. And essentially this and that is good. How many marks now? 4. And of course the final answer, 5. You can say, well, writing some areas properly in terms of those specific triangles and everything we needed to do could give us the extra mark. Otherwise, I don't see any other reason for a mark in what we did. Okay, now let's handle 3.5. So 3.5 reads a point in the first quadrant. So can you see we are given those coordinates instead of looking for them? So we plug them back in. So this is 6 and 3. Does it make sense? Yes. This point is below F, but it's certainly above, sorry, it's below E, but it's certainly above F. Because if we were to draw a horizontal line, you know, and just check, take it, put it across, can you see this cuts above the point F? So it makes sense. So we don't even need to think, okay, the examiner here is thumb sucking this one. So it's making sense in this scenario. So it's cutting us a bit of terrible amount of work we needed to do. Now we're told that A, B, C, and D form a rectangle with point D in the first quadrant. Obviously, this could have been a disaster if we're not told where that D is, because there's a lot for us to consider. But the nice thing is we already know that we've got a 90-degree angle here. So it means D should be somewhere up there, isn't it? Yes, so let's form our rectangle nicely. So we know that a rectangle has a pair of opposite sides that are equal and parallel. They are equal in length and parallel. Okay. So this means we take our friend. Fortunately, it's encroaching onto the words there, but what can we do? So we do the same thing here. Why doesn't it reach? Can't go. This one must not make me marmos. Is it mar? I don't want to be marmos. I want to be slemos. Okay, just a moment. Alright guys, so we've got our nice rectangle there. So we know that also that angle should be 90 degrees because all angles in a rectangle are 90 degrees. So that is point D. Again, this would need us to perhaps think about how we will find those coordinates, right? So question says calculate the coordinates of D. Easy stuff. Okay, so there are many ways in which we can do this business. You know, what I often like to do is to, okay, it's just 2 marks. So this means we should not struggle. Okay, this means we should not struggle. So if we can use symmetry in this manner, we say, if I'm looking at C as my reference point, how did I drop it to perhaps point B? I took point C and moved it to the right horizontally, 6. To get to -2, we said -6 plus 4. So this means we moved that point 4 units to the right. And then how many units down? From 7 to -1, it means we moved it 8 units down. All right. So that's how I'm thinking about it. So if that's what we did, we can ask ourselves, by how much must we have moved D to A? But perhaps the better way to look at it is to say, we moved B instead. We moved B, how many units to the left? From -2 to 6, it means we subtracted 4 units, right? So this means we moved this point 4 units to the left. And by how many units did we go up? Yes, -1 to 7. It means we added 8 units. Right. So if that's what we did, that's exactly what we're going to do also for A. So we're going to move it across first and then move it up the same way. So we're going to say 6 minus 4 goes to 2. So here we can do it by But again, remember, the question is clear. We need to calculate, so we can't just write the answer. So all I can say is that D, guys, is the point where I will take A, which is 6, and subtract 4 units, because I'm moving it 4 units to the left. Is 2, I take the Y value and I move it up 8 units. Okay, so we can say therefore D, 6 minus 4 is 2, 4 plus 8 is 14. Okay, nice and easy. It's done. So we've shown the calculation, but we chose a smart technique, or a smart approach, if you will. Okay, I don't need those arrows. Okay, right. So that's what we have, guys. So there's nothing more, nothing less. We only get 2 marks. Of course, I think since the question was clear that we need to perform a calculation, we can give a mark for an attempt to show a calculation and then the final answer. But an answer only, a student is going to lose a mark by not adhering to instruction. Right. So I wasn't answering the question. Goodness. This happens all the time, so please, guys, guard against this problem. All right, so we've got 3.5.2. Let's finish this question before we lose too much time. As you can see, guys, a bit of time can be lost in this section. This is why it is important to start with these very labor-intensive sections. Take a bit of time to get them done. Then race through those easy sections. And then, of course, there's only one easy section. It's question 1 and 2. The rest is not so easy. Okay. Anyway, so we've got 3.5.2a. Goodness, they're adopting this IEB nonsense now. This is unnecessary. Should not have it. Anyway, but for the context it makes sense, because we are talking about another structure within this structure. Okay, so we're told that a circle is drawn through points A, B, and C. Okay, so there's a circle. Is yellow gonna be good enough? So A, B, and C. So we've got a circle trying to pass through there, but this one is not gonna be quite. Yeah, I knew it. I need to think about it nicely. So this one should be a bit outrageous on that side. Yeah, then we move it nicely. Okay, let's just move it a bit so that I don't have issues. Just a bit, yeah. Okay, so it looks like we have our nice circle right through those points. Of course, it's trying to defeat me now. Hey, wena man. Skantlwaela wena man. Skantlwaela wena man. Okay, I don't think there's a better way for me to show this circle. So there is our circle. So we need to calculate the coordinates of the center. So we can see that the theorem of this issue here, so the center is going to be the midpoint of AC. Why? Because this is 90 degrees. So we need to first make a declaration that AC is the diameter. This is the converse of angle in the semicircle. Right. So if this is the case, we can say the center, this implies that the center is going to be such that we've got x at A plus x at C over 2 is to y at A all over 2. Right. Say, which implies that our center is going to be x at A is 6 minus 6 over 2. This is 3 plus 7 over 2. Right, we can say therefore our center here is going to be 0 and 5. It's literally the y-intercept of this line. Okay, cool. That's it. That's it. I do believe, though, this story here would make a bit of sense in the final answer. The rest is too easy. But since we were told to calculate, we need to showcase a calculation. Of course, one can think about giving the mark here, where we portray that we've calculated these coordinates rather than any other means. But I feel that statement is more powerful, why we would choose to use this question would have been best asked as determined rather. But again, it's not a big deal. If we show a calculation in anything we've done, we have done okay. Right, folks, so let's get to the next one. It says determine the equation of the circle in the form x minus a all squared equals y minus b all squared equals r squared. Of course, this is easy. So we've got essentially the center, and we've got a point at the circumference C and B. So this is easy. So we can say the circle is such that x minus 0 all squared plus y minus 5 all squared is equal to r squared through point B minus 2 and minus 1. We know that we've got minus 2 minus 0 all squared plus minus 1 minus 5 all squared equals r squared. Therefore, r squared is, so this is 4 plus 36. So that's 40. You can say, therefore, the equation is x minus 0 all squared plus y minus 5 all squared equals 40. Remember, guys, we were given an instruction on how to present our answer. Yes, there's nothing wrong for a student who will simplify the first bracket into just x squared. But be very careful when a manner in which the answer should be. We need to present the answer as requested. Right, so writing it this way is good. Substituting the point is good. And giving the final answer. Okay, guys, easy 24 marks to score here. And as you can see, guys, a bit of time got lost here in the process. Okay, cool. We'll carry on. Alright, guys, let's carry on. Kind of got interrupted. As I'm doing this paper, I'm actually on duty, so interruptions, folks. But hey, let's get it across so that you guys can enjoy this and perhaps get closer to that good mark. Right, we are given information on the diagram below that a circle here centered at M with the equation Now it's in the expanded form, so this is not very useful. So obviously, folks, we can quickly write this in standard form, Right, so we're going to have x, between the x terms there's a negative, so half of 4 is going to be 2. Right, y, the sign between the y terms is plus, half of 10 is 5. Then we get minus 19 plus 4, that gives us minus 15. Minus 15 plus 25 is just 10, okay? Right. Yes, it's 10. So this is the best way to write this. Right, is drawn, and we can see it from A, with this the point T is to 0, and we can see it's on the x-axis. So it's either an x-intercept of this line through the center or the tangent, essentially. So we're told here that a tangent is drawn to touch the circle at P, right? So triangle APM is drawn, okay, right? And we are told that AP is 2 root 10. So what do we know, guys? We know that the tangent always meets the radius at a right angle. Okay, so what can we do here? Well, we can find the coordinates of the center. It's going to be just 2 and minus 5 from the equation that we were given. Is there anything at this point? No. Right, so what are we going to be able to do here? Not much. Not much. We're not given a lot, so we are not at liberty to do much. Goodness. Right. How will we find the coordinates of T? Yeah, we are really not we are not in good shape. So this looks like we are going to have to think about it. But hey, oh yeah, the other thing that we can do here is that we can find the radius. The radius is just the square root of 10. Okay, so we've got this. So if we've got the square root of 10, we can use Pythagoras to find essentially MA. And once we have MA, we use the distance formula, we will find T. Okay, it's coming up nicely now. All right, so again, we can see that if we've got the coordinates of A, would we be able to find the coordinates of P? At this stage, it's going to require us to struggle a bit, because what I'm seeing is that we will have a distance formula here and a distance formula there, but the problem is that it's going to introduce squares. We don't like that. Okay, we don't like that, but here's what we can do. We can find the equation of this line, because once we get the coordinates of T, we will be able to find the equation of this line. Once we have that equation, doesn't look like it's going to be that useful, is it? Okay, it looks like P remains a bit elusive for now. Excuse me. So we can't really make up our minds as yet. But remember, guys, we don't want to spend too much time thinking about it. If we've done a bit of what we can, and we can see that we've uncovered a bit, that's good enough. The rest, we can skim and scan these questions and see if P is ever meaningful or not. Right? If we see here, we want to know why is APM 90 degrees. Tangent perpendicular to radius. Calculate the coordinates of M. So if the question says we need to calculate, this means we need to show how to complete the square, because we can't just come up with the final answer. The length of the radius is good. We know how we're going to do it. We need to show that T is 3. We've got a plan. Another circle centered at N with the equation. All right. So we've got a new equation here. So this means it's going to require us to consider some construction and some other things. And we can see there's no way where we need to worry about point P. So we know that, of course. Let's pick up the easy marks quickly. So 4.1, we need to give a reason why APM is 90 degrees. You can say this is the tangent, always perpendicular to radius. Okay, I would write APM is 90 degrees because the tangent is always perpendicular to radius. Okay, easy 1 mark. 4.2, we've got 4.2.1. We need to calculate the coordinates of M. Now, when the question says calculate, guys, we've got to show it. So we've got x squared minus 4x plus y squared plus 10y plus 19 is equal to 0. So we need to show everything, unfortunately. So we've got x squared minus 4x plus. We take half of the coefficient of x, we square it, plus y squared plus 10y plus, we take half of 10, the coefficient of y, we square it, we transpose 19. Then we add the whole thing that we have done. So unfortunately, when the question says calculate, guys, there's no cutting the corners. We've got to go about it as we know. Again, it goes back to saying completing the square is not examinable. Rubbish. It is, because look at the question here. It actually dictates that we do it. Not doing a calculation, guys, is a crime. It's an offense. Half of 4 is 2, we saw. Y plus half of 10 is 5. And we saw that we end up with this. From here, we can deduce that therefore M, the center, is going to be 2 and minus 5. Done. Okay, so we did show a bit of a calculation, and we have to. We can't just write this without justifying it. Because if it says calculate, guys, we're going to get a mark for all those gymnastics, right? And of course, rounding up there, that's the goal. We get a second mark, and we get our final mark. Okay, be very careful, guys, on how questions are to be answered as per specific instructions. Right, we need the length of PM, the radius, so we know that PM is going to be the square root of 10 units. We don't need to do anything there. Easy 1 mark. So what do we have? 4.3. 4.3 requires us to show that T is 3 degrees. So we will start by saying in triangle APM. We now know that essentially we're looking for AM. So we can say AM squared is going to be equal to MP squared plus AP squared. This is from Pythagoras. Nice. So what is this? We're going to have x at m minus, perhaps let's start with a, so that t doesn't become a disaster. So we've got x at a minus x at m all squared plus y at a minus y at m all squared equals mp squared plus AP squared. Now we substitute. We've got t minus 2 all squared. We've got 0 plus 5 all squared equals MP. We found it now, or PM. This is square root 10 squared plus AP. This is 2 root 10 all squared. So we know that essentially we want to keep this bracket t minus 2 all squared plus. This is 25 equals 10 plus this is 4 by 10, this is 40. So we can go on t minus 2 all squared. This is 50 minus 25, which is 25. Okay, so now we do our gymnastics of inverse operations there. What we do to one side, we always do to the other because this is an equation, so we need to balance things. So this implies that t minus 2 is equal to plus or minus 5. But now we know that this is on the negative x-axis, so we don't need to worry about other things. We can say therefore t is, so this should be minus 5. Minus 5 plus 2 is indeed minus 3. So it's done. Okay, again, this gave us a bit of a runaround, but hey, we know what to do. Great stuff. So folks, how many marks here? 4. I do believe that statement is key. The substitutions are key. The operations very much key. Even though the answer was given, I think how we arrive at it is also an important issue. Okay, right, so we've got 4.3 under our belt, so we've got minus 3 there. Right, so let's go to 4.4. Now 4.4 introduces a situation, so this is 4.4.1. We are told that another circle centered at N with this equation, okay, is drawn. Now we're told that this center N lies on MA produced. So obviously MA produced, it means this center could be that side, it could be this side. So we don't know where this center is, essentially. So MA produced, since we don't have a space on that side, but we can try. Let's first do this. So questions like this, folks, need a bit of time as well as planning, because we can't just jump in. So we can produce it to this side or that side. Obviously, once we are told something is produced, we need to consider all possibilities. So N can be anywhere on this line. It can be here. N can be here at the circumference. It can be outside. It can be perhaps in here. It can be at this circumference. It can be there. N can be, of course, we already have A, so N can be on that side. So these are all possibilities for N. And we are told here that the equation of MA produced is y equals minus x minus 3. So this tells us that this line cuts the y-axis at minus 3. And obviously, since that is minus 3, it gives us a minus 1 in terms of the gradient. So this is the equation of this particular line. Okay. Now, the very first question asks us to write down the coordinates of N. Okay. Now we gotta think about it. What is important is to look, we've got the equation, but instead of the y value, we've got a minus e. Now, if the question just says we need to write down, we need to be careful about what we want to do. What would be the y value of this issue? Yes, you've answered correctly. We need to substitute 5 there because we've got the equation. So wherever this center is, we will be able to locate it nicely. So when we plug in minus 5 there, we get minus 8. Okay, right. So we know that, okay, if it is minus 8, it's a point in the fourth quadrant. So it means it's going to be to this side. So this means this point is anywhere from this particular one here to perhaps this one over there to perhaps that one over there. So we don't care at this stage where it is. We just know this is a point in the fourth quadrant. So we're going to write it because the question just said we need to write it. So we know that this point N is going to be 5. The opposite of the x1 inside the bracket is 2. Now the y value, we just had to substitute the x value into this equation, because if you write e, you lose a mark. Ne? So we're going to write here that this is going to be minus 8. So essentially we get a mark for each. Although the other one was a bit more work. And the good thing is we were not told to showcase this. So now we've got these 2 positions, or 3 positions technically, to have to consider for this point N, because now those points, each one represent a point in the fourth quadrant. So it can be any one of those, including the one at the circumference. In fact, there's more points to consider. Okay, so we've got 1, 2, 3, 4 points to think about in terms of possibilities for this point N of ours. Okay, so N is still, oh, by the way, I'm being silly. This one is not to be a consideration at all. Why? Because we know the y value. So this is already out. So that point is out. So it can be any one of these 3 now. Okay? Because we don't know where these are going to be. Since we can see that this is already minus 5, and we know that the radius of this circle is square root of 10. Square root of 10 is going to be 3 comma something. So it's going to be 8 comma some change. So if the radius is 8 comma some change, and we're looking at minus 8, so this is somewhat suggesting that this point is inside. So it means, again, these ones are going off. See, we're narrowing things down to exactly what we are going to have. So this is clear that, okay, we don't have this one. Because remember, this point is a certain distance from M. So it's going to be 3 units. So 3 units, this radius directly below, it's 8 comma something. Sorry, it's 8 comma, yes, it's 8 comma something. Now 8, perhaps it's somewhere over here. Maybe let's make it a bit better. And say most likely this is a point over here. Okay, so that's a point over there. So it means this point is inside that circle. So it helps guys to sit down for these kinds of questions, because trust me, rushing through these questions would mean not answering adequately. Yes, by some coincidence we can run into the answer, but sometimes we just lose marks because of panicking. So 4.4.2, now it says we need to determine whether these 2 circles centered at M and the one at N, will they intersect, touch externally, or do not intersect at all? So again, this is one of those questions, but I would think the whole question is a higher grade. Of course, this one being the main question that is higher grade. Okay, so what we need to think about is, what is the radius of this circle? The radius is essentially the square root of 40. Now this is 4 times 10, so that's going to be 2 root 10. Ne? So the radius is 2 root 10. Okay, all right, okay. And we can see that this radius is basically double the radius of our original circle. So what I can do now is to do this. I already know that I've got this line, which is 2 root 10. Of course, this is really ridiculous at this point. What I'm doing is not exactly correct. But all I want is to say from this is how my circle is going to go. But the good thing is that this one allows me to do it. But it doesn't always allow, okay? So we can assume a circle going around like that. And with n as the center, of course, we will try and center this at n. From what I can see, it looks like they do intersect, but actually no. But remember, with a nice and proper stuff like a compass, we can actually be able to determine if this is the case at all. Right? I just want to center this properly so that this is at circumference. But it doesn't look like it's doing what I want. Okay, let's do it better. I think I can win if I play my cards right. Of course, guys, here I'm wasting your time. But then I've got to give you guys a bit of, a bit of a feel of what this is supposed to be. Just need to give you guys a bit of a feel. Just so that you've got a nice feel. These kinds of questions are not easy to just do without a bit of a structure, you see. Okay, sorry. Just trying to go through these points to try and get my circle nicely centered. Okay, let's try to move it properly. Okay. Okay. Looks like we are winning. Right. So obviously, guys, this is what we get. The way it looks like we are winning. So this is telling us that our circle is intersecting, but I feel like what I'm doing is a risk, you see. This is dangerous. What I'm doing is dangerous, guys. Let's see. Let's just be careful. Let me just take it out. I feel like no, man. It's giving us... You see, as I'm thinking, remember, this radius, that which I'm doing there is dangerous, but what is more important is to use the radius of this circle. Rather. You see? Because the radius of this circle, we are doubling that one. So I think this is a best measure for our troubles here. Because from N, so from N we need to move. It's just that now the alignment is messing with me now. Okay, guys. Anyway, copy and paste. Yes. Now this would be the best plan. You see, that's what I wanted to showcase, that essentially we'd be selling ourselves a very deadly weapon. Can you see from this center along this line, this is going to fall outside, and yet if we used that line, since it was not necessarily drawn to scale, would be in trouble. So it's best to use the radius. Okay, again folks, I'm happy the fact that I'm able to show that this thing is not to be done carelessly. Whatever we do, we need to carefully consider what we are doing. I don't like the circle. Yeah, that is nice and solid. Of course, we want to assume that the center is where we see it. And from what I can see, this is not too bad. So this is the circle that we have. Excuse me. So this looks perfect. So always plan accordingly. But if you use a compass nicely, guys, this is going to be great. So all you do is just measure the radius of the original circle here. Then you double that. Then this being the center, just use a pencil. This is going to come out as a nice circle. Of course, make sure that you do it well so that everything looks right. Can you see? With the right approach, we don't get a wrong information, because we would be questioning our results if we're not using the right measure. Okay, so the relationship was that the radius of this circle is double the radius of the other one. And of course, we still have point M here, the center of this other one, and we've got point N over there. Right, so we can clearly see these circles don't touch, but we can't use a drawing, okay, because it's not necessarily to scale, but this is for us to gain a bit of an idea. So what are we going to say? Now remember, guys, we need to think about two possibilities. If these circles touch, they can touch externally, right? Once. Or they can touch internally once. Right? Right. And they can touch 2 times. Like that. Or if they don't touch, remember, the question here says, will they intersect, which is probably this scenario right here, or touch externally. This would be the scenario over there. But again, they could easily touch internally. It's possible. Or they would not touch, such that we have a situation like this. All right? And this is when they do not touch at all. But again, this can also be a situation where they don't touch when they are concentric, meaning they have the same center. But this one is already out because they don't have the same center. So this means it could be the situation where the center of the smaller circle is like that, and then the bigger circle is also sitting like that with its center over there. So this means we need to evaluate the distance between the centers, essentially, because I think the manner in which this is looking like is this one. So we need to think about that. Right, and of course we need to consider all these other circles. So this question, guys, is chowing our time, unfortunately. So what we can see, folks, is that the distance between their centers is what can give us an indication. But what would be that distance between their centers? It's not even the difference between the radii. This distance is going to be smaller than the radii. And this already highlights this fact, that when the distance between their radii is small, while their radii are not equal, so this is clear that these are not going to touch. It's going to be this scenario. So what are we going to say? The distance between the radii is less than, the difference between the radii, which would be the case here. Remember that distance is the radius of the bigger one minus the radius of the smaller one. That would be the distance. So this is when they touch internally. But if we make that distance smaller, it means we are moving the smaller circle inward a bit, like so. And when we do that, it already tells us that they will never touch because the radii are not equal, and we've moved that circle a bit more inner, so we are safe. So our job is very easy now, guys. We're going to say here, well, what is mn? Mn is going to be the square root of x at n minus x at m all squared, y at n minus y at m all squared. Okay, this is the square root of x at n. We've got 5 minus that one at m is 2 all squared into. We've got y at n. It's minus 8 minus 5. It's going to be like that. So let's see what is that distance. So we can see what we have here is, oh, my calculator is losing the labels on the buttons. My lord, I need a new calculator. Plus into minus 8 plus 5 all squared. Please, guys, ensure that these things, this is 3 root 2 units. So what do we see about this distance, guys? We can see that the distance is shorter than the difference of the radii, which means this is the scenario that we are talking about. I don't know why I put it there actually. So that is the case, which is nothing but the same as what we just explored. So just trying to think of how to phrase this now. What would mean? First of all, I think we need to compare the radii. You can say also, we know that the radius of n is going to be the square root of 40, which is equal to 2 root 10 units. While the radius of m is basically root 10 units, just to show that these are not equal. All right. So I don't know, how will I phrase the answer now? Holy cross. Of course, guys, do think about how one is to provide this answer. Trust me, cutting the corners too much is not good, because we need to give a solid answer here. We can say, okay, all right, okay, therefore Rn is greater than Rm. In fact, double. So we can say, well, we can also say, therefore, Mn is less than the difference of Rn minus Rm, isn't it? This is what it is. Or perhaps we need to showcase this. I was thinking about it. Okay, now this makes a bit of sense. We have a clue now what to do. So what we're gonna say, if this is the case, we can say this implies that Rn minus Rm is going to be essentially 2 root 10 minus root 10, which is just root 10 units. So we can say, therefore, Mn is less than Rn minus Rm, But is there any other restriction I can put? While, whereas, because I'm the writing. Whereas Rn is greater than Rm. You can say therefore the two circles never intersect at all. I think once we've made our argument, we are saying that Mn, the distance between the centers, is less than the difference between the two, because the way they look, they would either be concentric circles, but now they already don't have the same center. So if that distance between the radii is not, I think the restriction would have been when the two circles touch internally. Okay, stuff like this. Yeah, if we had that situation, I think that's the restriction for us here. So once you move the smaller circle a bit in, then they don't touch. And I think this is a valid reason. Okay, that was something else. That was something else. As you can see, I have to really consider how I'm going to phrase, how I'm going to phrase my answer. Okay, guys. So for me, these 5 marks, we need to get a mark for the conclusion, and I do feel that this reason is key. And of course, this calculation is quite important. That calculation is quite important. And of course, to compare the two radii, I suppose. I mean, the other one we already have, so I don't think for both, but perhaps for this one. Okay, otherwise, guys, if we put a valid reason, we should be safe. As you can see here, even though you've done a good job and you're convinced, it's not so easy to convince the other person who's going to be handling the marking process. But I think we've done our job, folks. As you can see, we go through a few, issues to think about it, and again trying to annotate our diagram in the best way possible. Sometimes we even get the brightest of ideas that, okay, this is the case, this is what happens. And of course, some of the issues may have not been issues that are part of the standard teaching, but there's no excuse, guys. We need to know circles very well. We need to know triangles very well, circles very well, rectangles or parallelograms in essence, all quadrilaterals that we can imagine. We need to know them all, especially the ones that are common. We need to know about cones, rectangular prisms, cubes, even spheres and hemispheres. We need to know these things because they are part of the previous grades teachings. Anyway, folks, let's not preach. Let's jump into trigonometry as fast as possible. All right, question 5. We've got 5.1. We are told that square root 3 times sine alpha minus 2 is 0. So we need to isolate the trig ratio here. Going to be 2 over root 3. Okay, cool. Now we're told that x is an element. We can't have x though. This should be alpha. See, examiners are sleeping too. So if this is greater than 90 and yet less than 270, and we can see that our sign is positive, so this means we're sitting in the second quadrant. We already know what is going to be our problems here, so we just get ourselves ready. Got x, the origin. Y, we know that our terminal arm is there. we don't need a second invitation, and this is our alpha, because a value greater than 90 less than 270 is an obtuse angle, for sine being positive, of course. Otherwise, it could easily have been a reflex angle if sine was negative. Okay, good stuff. So folks, what do we have? We've got 2 as the opposite, root 3 as the hypotenuse according to the definition of sine. Again, we don't wait, so we're going to say x squared plus y squared equals r squared. This is from a very famous theorem. So x is what we're interested in. So here we know that our x is going to be minus the square root of, we say this is going to be 3 minus 4. So what? That's not kalwagabi. This is not working, is it? We can't take a square root of a negative. What are these examiners doing now? Examiners, what are you doing? What are you doing? Oh, I wrote my own things. Okay, it's not examiners, it's me. Excuse my nonsense. See, sometimes it's easy to project things to other people, only to find that the fault is with me. Oops. Sorry, my examiners, I'm being silly. So 13 minus 4 is what? 9. Ne? Yes, 13 minus 4 is 9. So this means this is going to be minus 3. Because we're on the negative x-axis. Okay. Sorry for that, guys. See, incorrect copying leads to a disastrous ending. So one needs to make sure that when something doesn't add up, we go back and find out, did we do the right thing? So we're supposed to evaluate tan of alpha. Now tan of alpha is going to be opposite over adjacent, so it's going to be minus 2 over 3. As we can see, there's 4 marks there. Why? There's 1 mark for defining tan. There's 1 mark for sorting up our expression. 1 mark for the diagram. 1 mark for the x value. See? Very spread out stuff here. Okay, 5.1.2, we need to sort up sine 90 degrees minus alpha. So this is going to be equal to cos alpha using our cofunctions. Now cos alpha is going to be adjacent over hypotenuse, so it's going to be minus 3 over root 13. Nobody told us to rationalize in grade 12. We can avoid this issue, so we get a mark for that and for defining our cos. So here the examiners were a little bit friendly. So let's rush 5.2. So 5.2, we need to consider this. So now we need to simplify to a single trigonometric ratio. Okay, so that's easy. Sine 180 plus theta times cos of 90 degrees plus theta, all divided by tan theta times cos of minus theta. So of course, guys, we know what to do here. Reduction, reduction, reduction. Sine of 180 plus is going to be minus sine theta. Cos of 90 plus, cos is negative in the second quadrant. So we do the cofunction. It's going to be minus sine theta. All divided by tan theta is sine theta over cos theta. Now cos of theta is positive cos theta. negative angles. Okay, good. So this one, by the way, we need to show this as a fraction once we see a fraction next to it, so that we don't run the risk of messing up. So this is what we have, guys. And this sign that survives can take one of the signs. So what do we end up with? So negative times negative is positive, so it's going to be just sine theta. Easy. No issues here. So how many marks do we score for the reductions? Each one, that's a mark, as well as the 10 identity in the final answer. So again, examiners chose an easy route. But remember, guys, we need to check. So let's say theta is 2 degrees. So we plug it here and see what we get, and we plug it over there and see what we get, because we may have made a mistake, you see. So we've got sine of 180 plus 2. This is being multiplied to, okay, let me do this. Please be very careful of brackets here. Cos of minus 2 degrees divided by tan of 2 degrees times cos of minus 2. Actually, I made a mistake above. I put the minus 2 there. That was supposed to be cos of 90 plus 2. Okay? So the answer I get is some 0,03489. Let's cut it here. Right, so let's check when we put sine of 2 degrees, what do we get? Same stuff. So once we get this, guys, we know that there is no way in hell, if not in heaven, that we made a meal of that situation. Okay, guys, let's move. So we've got 5.3. Now we need to find the general solution of this business right here. Okay, good. Sine x equals 1 minus cos 2x. Now, this is easy because once we say sine, we can convert this and make it sine so that we have a nice quadratic. So this means sine x equals 1 minus, here this is 1 minus 2 sine squared x. So we always end up with some quadratics, eh? We should be comfortable with this. So it's 1 minus 1 plus 2 sine squared x. So we can already see that we've got 2 sine squared x minus sine x equal to 0. Because the ones essentially cancel. So what do? We factorize by taking out sine x into 2 sine x minus 1 equal to 0. This implies that sine x is equal to 0, or sine x is a half. Okay, so these are all valid stuff. So we use our lovely gymnastics. So we know that x is going to be equal to sine, arc sine of 0 plus k times 360, or x is going to be 180 degrees minus the arc sine of 0, all of that, or we get to the second one, x is going to be the arc sine of 0,5 plus k times 360 degrees, or x is going to be 180 degrees minus the arc sine of 0,5 plus k 360 degrees, where k is an element of integers. Okay, just trying to squash as much as possible. At this stage, we can make a conclusion, folks, so that therefore x is going to be sine of 0 is just 0 degrees, or 180 minus 0 is just 180 degrees plus k times 360 degrees, or we get to here, it's going to be 30 degrees, or the fourth one is 180 minus 30 is going to be 150 degrees, where k is an element of integers. Those are the general solutions. Okay, easy stuff, not a big deal. So when we use our identities, we win. When we factorize, we win. Perhaps those solutions, we win. Then the general solutions, 1, 2, 3, 4. So we've got 1, 2, 3, 4. We're getting 6 marks. Okay, so unfortunately, that mark must not be there. All right, folks, so this is it. This should have been 7 marks though, because we cannot ignore this step or even ignore factorizations or using our identities. But this is done. Right, my man. Don't go away. King away. Scandine. Nice. So we're going to 5.4. But since it looks like we are having a situation, we might as well go to the next page. So we've got 5.4.1. This one says we need to look at this identity and we need to prove it. Okay, cool. It's just 2 marks, not a big deal. We know that we're going to take the left-hand side, which is sine A plus B plus sine A minus B. This is going to be sine A cos B plus cos A sine B plus, that one becomes sine A cos B minus cos A sine B. Now what do we have here? Sine A cos B plus cos A sine B plus, this is sine A cos B minus cos A sine B. So this takes care of that. And those are like terms, so we get 2 sine A cos B, which is equal to the right-hand side. Great stuff. So this is easy. So I guess here what was important was the 2 expansions. The rest, adding like terms, is too easy, né? So 5.4.2 says, hence or otherwise, show without using a calculator that, again, this is just another way of proving the identity, because I mean, if one thinks about it, where would we use a calculator? It's not possible, is it? It's ridiculous. So that is just a weak question in my opinion. Why would you say without using a calculator? How is it possible to use a calculator? Is it? I doubt. I truly doubt. But again, maybe I'm being silly myself. Sometimes I need to think about what I'm saying. So perhaps one could easily choose a value for x, for example, which would be true anyway. All right, guys. So with this kind of a question, we can see we have an issue. The right-hand side looks a bit more complex, as much as the left hand side is also very complex. But anyway, which one is best? Maybe the left hand side, since there's 2 terms on the numerator, 2 terms on the denominator. We want to get rid of this. Of course, if the question says hence, it means we could actually use what we have here. You know, maybe it's possible. But let's first write the left hand side, which I think is the best one to start with. Left hand side, we've got sine 7x plus sine 3x all over 2. No. Where's the 2? Come on. Stop writing things that were not given when. Okay, this is what we've got. So how are we going to handle this? Okay, guys. I'm trying to see now. 7 could be 5 plus 2, ne? And then 3 is 5 minus 2. So we can play into the hands of this identity. So this could be thought of as sine of 5 plus 2. Sorry, 5x plus 2x. Right? And then we've got plus sine 3x is as good as 5x minus 2x. Because we're trying to create a situation like that. You see, this is similar. Yeah, strategy, students. Divided by, if we look at the next one, what do we have? We've got, do we really want to do this one? But yeah, we don't have much of a choice, do we? So we can say this is cos of 5x plus 2x as well, plus cos of 5x minus 2x. Since we've done that, we might as well do that here. Now look at our identity. It's coming up nicely. So this is going to be just 2 times cos of 5. Sorry, sine of 5 times cos of 2. This is exactly what this is. So we can say this is essentially simplifying to the identity we proved. So this is going to be 2 sine of the first angle times cos of the second angle. Divided by. Now at the bottom, we don't have that much luxury, do we? Yikes. Well, we just have to expand, I suppose. So let's see, what do we get here, guys? We get cos 5x cos 2x minus sine 5x sine 2x, plus here we're going to get cos 5x cos 2x, the sign changes to plus, okay. Unfortunately, it goes that way. Right. Now, we leave that one as it is. 2 sine 5x cos 2x. All divided by what we see here. Cos 5x cos 2x. Hey, I can't cancel this. And that they add, so we end up with a 2 cos 5x cos 2x. Okay. And we've got minus sine 5 2x. Okay, it's getting us there, because this one actually cancels the other one. Nice and easy. So those ones are gone. So we no longer need this long, lengthy business. just put it right. Okay, so what do we have here? We've got 2, taking out 2. So we've got sine 5x cos 2x over cos 5x times cos 2x. Come on. What is this thing here? Am I doing the right thing? Okay. But what I see... Hi man. Oh yes, it's working. Actually, cos 2x and cos 2x should go. Oh, great. I should not even have this. Send for no panic. Now, sine 5x over cos 5x is going to be tan 5x, which is done. Of course, this one said prove. So we kind of... I mean, this is an identity. This is equal to the right-hand side. It's done, it's dusted, it's finished. Okay, right. Now, guys, just to help students, practice a bit here. How about we do it the other way? Let's just do it over here to avoid writing too much. So how about we use our identities instead, the normal ones. So we will say this is sine. Let's say we chose a different approach. So this is going to be sine 7x. We can say this is 4x plus 3x. Since we see sine 3x over there. So this is plus sine 3x. We keep that over, this is cos of 4x plus 3x plus cos 3x. We'll leave that there. What are we going to do now? Expand. So this is sine 4x cos 3x plus sine 3x. Oh, dog, what am I doing? So this is going to be plus cos 4x sine 3x, okay? Sine 3x over here. Then we're going to get here cos 4x cos 3x plus, not plus, but it changes to minus, sine 4x sine 3x plus cos 3x. Right. So what do we want to do, guys? We want to get rid of as much as possible. So now cos 4x is not going to give us what we want, so we need to change it. So we change sign here. This is basically 2 sine 2x times cos 2x. Okay, times cos 3x plus, now cos here, because we see sine 3x, we want to eliminate this one, so it's best to use cos here. So this is going to be 2 cos squared 2x minus 1 times sine 3x plus sine 3x. So these other roots can be very challenging. So sometimes you can see that the easiest route is what is proposed. But hey, what if you didn't see it or you don't trust it? Now we go. Here we can change cos. But again, what are we trying to get rid of? In here, we're not really at liberty to eliminate much. But I think we've got cos 3x here. So if we factorize here between these two, we're gonna win, right? I do feel this must meet with that so that we can eliminate something there. Is it gonna help us? Yeah, there's no other way. I think we need to group those two and factorize them. Otherwise, we're gonna run into some problems. Okay, let's see how it goes. So we take cos 3x into, we get here cos 4x. Okay, let's write it cos 4x plus 1. Yeah. And then minus, this one we can change already. This is going to be 2 sine 2x cos 2x times sine 3x. Okay, this is what we end up with. We move along nicely. We fold that one out. So we get 2 sine 2x cos 2x cos 3x plus 2 cos squared 2x sine 3x minus sine 3x plus sine 3x, all divided by, now what we want to do is to change some things here. So this is going to be cos 3x into, this one is as good as 2 cos squared 2x minus 1 plus 1. Minus here, there's nothing we can do here. We've got 2 sine 2x cos 2x sine 3x. Okay, let's see guys, sometimes it gets overwhelming. This is why sometimes it helps to choose wisely. But what I like is that this dude finally takes that one out. Sorry, not that one, but these ones go away. Now in the numerator we've got a common factor of the common factor here is cos 2x. You see, is cos 2x. Okay, let us see. 2 is common, we can take it out, right? And then yes, let's take 2 out as a common factor at the top. And what else is common there? Is cos 2x. Ne? So we write cos 2x into, now what we end up with here is sine 2x cos 3x plus, what remains here is cos 2x sine 3x. All this over let's see. So here we end up with cos 3x. Okay, we end up with just 2 cos 3x cos 2x, fact cos squared 2x minus 2 sine 2x times cos 2x times sine 3x. It's a long root, It's a long root. That identity on the inside is doing the good things there, but what we like is that we can take out cos 2x in the denominator as well. Okay, so we still have cos 2x into, this whole situation, it spells out sine of the first angle 2x plus the second angle 3x. Ne? Yes. In the denominator, we take out the highest common factor, which is 2 cos 2x. What do we end up with is cos 3x times cos 2x, right, minus, there we took cos 2x, we end up with, in fact, 2, then we end up with just sine 3x times sine 2x. Okay, as you can see, folks, the space, this is long, it's tiring, but what can you do? If this was your only way, then it was your only way. So what we like now is that this dude and that dude go away. As we shrink the top, that becomes sine 5x over. As we shrink this, it's going to be cos of the first angle minus, plus cos of the second angle. So this is going to be cos 3 plus 2, so this is going to be cos 5x. Okay, which is equal to the right hand side. So it could be done. As you can see, it fills up an entire page and it takes a lot of concentration. So sometimes taking the shortcuts offered is a wise thing to do. Right, let's get to question 6. So question 6 says, in the diagram below, the graph of f is a cos of x plus b. So first of all, we know that cos of 0 was meant to be a maximum of 1. But we see the maximum has gone up to 2. Okay? And the worst part is that this has moved to the left as well, because now that maximum falls right there. So if we see that 60, that's 0, so this should be minus 30 degrees. So this is good. Another way of looking at it, cos of 90 should be 0. So 60 plus 30, this should have been here. But now this has shifted to the left. $30. So this means we moved the graph 30 degrees to the left. But of course, the amplitude here, the amplitude or maximum, if we look at the maximum value, it becomes our coefficient here. And if we don't see anything, we can take it as such. Okay. So there's many ways of getting this done. So we know that our f of x is basically 2 cos of x plus 30 degrees. Nice and easy by just looking, understanding these graphs. So this is fine. Okay, this is drawn for the interval minus 180 to plus 180. Now the question says, use the graph to determine the values of a and b. So the good thing is we just have done it. And it didn't say calculate. The word determine it means we can do it by inspection. So we know that a is 2. All right. And b is plus 30 degrees. Nice and easy. No questions about it. So 6.2 says, draw the graph of sine 2x plus 1 for the interval. Show the intercepts with the axes as well as coordinates of the turning point. No problem. So what I know is that, guys, sine of 0 is 0, no matter what the angle is. But the next thing that's going to happen, we move that 1 unit up. So this sits over there. But remember, our graph's period has halved from 360 to 180 because of the coefficient. Now when we divide 180 by 4, we get a space of 45 degrees. So if we look at the scales here, if we say this is 15, 30, 45, 60. So this is indeed 15 degrees. So if we're moving 45, it means before 60 it's 45. So we expect to hit an x-intercept at, sorry, not x-intercept, but at 45 it was meant to be essentially 1. But now this is going to go to 2. Okay, good. And then we knew that also what would have happened at 180, which is an x-intercept. This would, is it an x-intercept at 180? Kanen, sine graph is minimum. Liar, yes. Sine is minimum. Ay, yeah, it's an x-intercept at 180. You see? Yeah, it would have been an x-intercept at 180, but now this is going to happen at 90. But that x-intercept was shifted up, so it goes here. Okay. Again, guys, you can do this, using the smallest scale, no problem. But for me, I just want to get the shape and move on. But when it comes to points of intersection, we need to make sure that what seems to be the one, we check if the two graphs are going to meet. Because sometimes it can catch us not really seeing things. Of course, we know, guys, at 135, this is 120 plus 15 is 135. It would have been minus 1. So minus 1 plus 1, it goes to 0. And at 180, this is what would have happened at 360. So it's going to be, what it was supposed to sit here. But now we add 1, so we go up to 1. So this is exactly what's going to happen here. And if we move to this side, so what was supposed to be the x-intercept? What am I trying to say? Minus 45, guys, was supposed to have 0. Minus 90, sorry. This is going to go to minus 45. But now, no, it was supposed to be minus 1. Minus 1 plus 1 is going to give us 0. It comes down here. Then we know that at minus 135, is it 135? Okay, minus 45 is over here at minus 90 actually. We are supposed to hit that value. And at minus 120, no, minus 135, there, we hit our maximum again. And then from there it goes to 1. Yo. Yes, guys, yes. So there's our graph, folks, and this is the graph of G. We label it, so it's done, dusted. Easy, guys, no struggles unnecessary there. So we've got our 3 marks. We move on. 6.3 says we need to write down the period of G. It's going to be 180. Right, you know it. As we can see there that from rest to rest, it's a period of 180. 120 minus 60 is 180. So this is good. 6.4, of course, guys, this is just easy, 1 mark here. So 6.4 says we need to determine the range of 2 times G. Okay. It's a set of Y values. Now, 2 times G. This means we're just going to say Y must be less than and equal to the maximum value times 2. So what is the maximum value times 2 here? This is 2 times 2. That's going to give us 4. Okay, let me show that product. And we're going to say minimum value times 2. The minimum value here was 0 originally. So we can say therefore the range Okay, just a moment. So therefore the range is going to be equal to y, set of y values such that y is less than or equal to c. I wrote a wrong thing here. So this is going to be 0 still, but it goes to 4. Of course, guys, write the answer only here is easy, but again, when I'm looking at the marks, I feel like it's necessary to show everything, you see, because I do believe, in fact, here, once you see 3 marks instead of 2 marks, it means an answer only is dangerous, actually. Yeah. So this is key. You need to get it done properly. So sometimes the mark allocation can highlight the fact that we need to do a bit more. Otherwise, an answer only, I don't know if it can be given full marks. Yeah, doesn't make sense for full marks for such a situation. So, yep, easy stuff otherwise. So 6.5 says, need to use the graphs to determine. You see, now there's a restriction, so we can't use other things here. If the question says use graphs, so it means we need to refrain from calculations that don't include the graph, but we can still perform calculations, but these calculations need to be influenced by the graphs. So sometimes some questions need a bit of careful approach. F of x is less than g of x for the interval minus 180 to 0. Okay, so we're looking at from here, nope, not there, but from there to there. Okay, let's see. When is f above? Okay, the graph of f here is above g only in that segment, including at 0. So yes, 0 is included. So we know that at 0, the graph of f, because this is f, is above the graph of g. They are equal there. So we know that that value was minus 90. Okay, so we know that where they are equal, it's minus 90. We can even check by plugging minus 90 into both graphs. You'll see that the same value of 1 is going to come up. So we can just say x must be less than and equal to 0 degrees, but greater than, we can't include the last one because they are equal at minus 90. So we are not to include minus 90, but we can include 0 because at 0, the graph of f is still above the graph of g. So be very careful of these ones. There's always these crazy situations happening. Now we want the tan of x plus b to be undefined. Now remember, the tangent here is the tangent of the x situation. Remember, where is this undefined? At the asymptotes. So under normal circumstances, what would be the asymptotes? Let's picture them. The asymptote should have been at 90, isn't it? Because 10 of 90 is undefined. That's where the asymptote should be. The second asymptote should be at minus 90 under normal circumstances, right? But now we are shifting this graph, the b value, and we know that the b value came out as 30 degrees. So it means we shift everything 30 degrees. So this means this asymptote is going to move to 60, and that asymptote moves to 120. Of course, these are going to be the new asymptotes with the shift. So again, it helps to think about what would have been, and then do the we do the shifting accordingly, right? So this means we're going to have the x values is going to be x equals these values, minus 120 degrees, comma 60 degrees. It's a list, isn't it? Or one can write x must be minus 120 or x must be minus 60. Now the other asymptote would have been at 270, but now 270 minus 30 is going to take us to 240, but 240 is not in that range, so we cannot think about that. So these are the only two values that we are getting, and it matches the mark allocation. All right, so that's it for 6.5. So let's look at 6.6. 6.6 says the graph of G is shifted 45 degrees to the left to obtain the new graph of P. And now we need to determine the equation of P in its simplest form. This question keeps on coming, guys. For those who watched my videos just before the trials, I promise you, you will see that video for paper 2 has all of these things in there. So guys, keep ignoring this channel, especially those who know it. You're gonna cry. This is equal to G. We're shifting this to the left, so we're gonna just add 45 degrees. Right? So this means the graph of F is the graph of G with 45 degrees added. So what does this imply? Means P of X is, what is the what is the graph of G? This is 2. No, there's no 2. It's basically sine of 2. Now instead of x, we're gonna write x plus 45 degrees. Right, and that is the 2x part, right? The graph of G was 2x, and then of course we add 1 because G had added 1. So this implies that P of x is going to be sine of 2 times 45 is going to be 90 degrees plus 2 times x is going to be 2x plus 1. You can say therefore P of x would be, we use cofunctions here, sine of 90 plus second quadrant, sine is positive, so this is going to be just cos 2x plus 1. Nice and easy. All right, guys, so again, we have explored this question multiple times, so I do feel students should not have any issues here. And of course, the question says determine, maybe to showcase the transformation is key and to write the final answer. The rest is as it should be expected. All right, guys, so this is 15 marks for all the troubles. So again, guys, I'm sure you enjoyed the graph because we are doing great. We are doing great, okay? Right. I think I need a cup of tea before we proceed into the 3D, or maybe let's finish the 3D and then I take a cup of tea before we handle our Euclidean geometry. Maybe let me do that. Let's just squash question 7. So question 7 says, in the diagram, AD is a vertical pole such that AD is perpendicular to BD. So this is all indicated. BD and C line the same horizontal plane. Okay, right, we normally shade this stuff. All right, so now we're fine. I told the pole is anchored at B, so no problem. BAD is theta indicated. DBC is alpha indicated, AD is H units indicated, and DB is equal to DC also shown. So we need to determine BD in terms of H, so that's not a problem. So we can see where to look. So that's the triangle, and the side we're interested in is opposite the given angle, and the side given is the adjacent side. So this is tan theta. So that gives us the tangent of theta. So we can just say tan theta is going to be the opposite, which is BD, over adjacent, which is H. So we can say therefore BD is going to be H tan theta. Done. So this can be easy, they can head. So this and that is good. So 7.2. I normally go systematic, but I'm chasing time, guys. I need to be at work and I'm tired. I'm on duty. And I have an appointment with the dentist, so it's going to be quite a disastrous day for me. Hence show that BC is the story. Okay. Now, what we see there for BC, this is an isosceles triangle. So it means this angle is going to be equal to that angle, meaning this is alpha. So we can use the sine rule here because we can see but why not the cosine rule? We've got the opposite side, we've got the adjacent side, and we've got the other adjacent side that we're looking for. Perhaps the cosine rule is going to be better than the sine rule. If we use the sine rule, it's going to be this over that, and this over that. So this is going to force us to look for this angle, which we can. I mean, this is 180 degrees minus 2 times alpha. Can be done. So we can use the sine rule, can use the cosine rule, whichever seems to work, we are good. But I think the cosine rule is straightforward. It avoids us calculating another angle and then struggling. So we can just say here, in triangle BDC or BCD, we know that DC squared is equal to BD squared plus BC squared minus 2 times BD times BC cos of that angle DBC. Right, that's the cosine rule. So DC squared is what? Is H tan theta is equal to BD, same story, H tan theta all squared plus BC squared, which is what we want, minus 2 times, if we look at this one, we've got H tan theta squared times cos of alpha. Okay, I'm just avoiding this long lengthy thing is, so this and that will take each other out and leave us alone, please. So what we're interested in is BC, so we transpose this guy to the other side. So what we end up with is BC squared equals 2 into, when we square here we get H squared tan squared theta times cos theta. Now so this is cos alpha, right? Why is this thing not coming out now? Why is it not coming out? Why is it not coming out? Here one. It's not coming out because we've got 2h tan theta here, but we don't have a square root. Abafits. Wirahalang biano. What is cooking here? Is not doing the good things now. See this one? Bad plan. What did I not execute correctly? BD and BC are the same. Yeah, my mistake was here. This was not the case. Goodness, how can I be so careless? Wrong. BC is still like BC here. Cos alpha. Yeah. I was wondering now why. You see. Now I'm happy. Okay, so we've got here essentially 2 times h tan theta times BC cos alpha. So we can divide by BC throughout, so we end up with BC equals 2h tan theta cos alpha, as it was supposed to be. Okay, cool. See, I was choking at the end. It happens when you're tired, so try to make sure, guys, these questions are out of the way while your brain is still eager to go through this paper. Okay, you don't want to be doing these questions under pressure, under stress, and of course with a bit of tiredness in there. So this is 4 marks. I think this is mark worthy. Substitutions, yeah. The gymnastic of dividing by BC. What else is here? Why not give a mark here? As long as we've done it perfectly, guys, we get 4 marks. No issues. So 7,3 says we need to then find the area of BDC. Okay, so we know that area of triangle BDC, when I use the area rule, is going to be half of BD times BC sine of alpha. Ne? We're not going to waste any of our time. What is BD? BD is h tan theta. So h is 5 times tan theta is 40 degrees. BC is 2 times 5 times tan 40 degrees times cos alpha is 25 degrees. And of course that times by sine of 25. Easy. So just hoy that into the calculator and we move 0,5 into 5 times the tangent of 40. But now here one needs to be very careful with brackets. This is 2 times 5 times the tangent of 40. And then that times by the cos of 25. then this is to be multiplied by sine of 25. I hope everything is good. Yes, it's good. So I'm getting a 6,74 to 2 decimal places square units. Okay. Nice and mpashasha. So all we had to do was just to simplify and substitute. So essentially writing the area rule is good, substituting in the answer in the manner that is required. Okay guys, our job is relatively done here, so I feel a bit fried now. I think before I start this one, let me just have a cup of tea and try to race through this before 8, because I'm needed at work at that time. Alright guys, so let's carry on. Question 8. Right, question 8 reads, we've got 8.1. We are told that in the diagram, O is the center, as the contour die1. Yeah. Cyclic quadrilateral ABCD and chord BD are drawn such that AD is equal to DC, so this is already indicated. DOC is 96 degrees, okay? So if we just analyze our diagram quickly, we know that this side is essentially equal to that side. Those are ready, and with ready, it means this component of that angle and that component of that angle should also be equal. So those are angles opposite equal sides of a triangle. Right. So that's the little bit that we can gather. Of course, furthermore, we know that the angle at center is 2 times the angle at circumference. So that should be half of 96. But also we understand that equal chords subtend equal angles at circumference of the same circle. Remember, the chords have to be in the same circle. If they are equal, they will subtend equal angles. Right, that's a little bit that we can do there. So let's get to business. 8.1.1. We need DBC. So we already know what we're looking for. So we know that 2 times angle DBC. Remember guys, when the question says calculate, we need to show a calculation is equal to essentially angle DOC. Why? We know that angle at center is equal to 2 times angle at circumference. Right. So this implies that 2 times DBC is 96 degrees. Therefore, DBC is going to be half of 96, which is going to be is 43. Ne? 48, sorry. Yebo, yes. So this is 48 degrees. Nice and easy. Done and dusted. Guys, please don't just write DBC is 48 degrees, angle at center. Nonsense. It doesn't work that way, ne? We need to show a calculation. We can't just come up with an answer. There's a clear instruction. Guys, not adhering to instructions, you will die. Remember, the examiners, when they write the memo, they don't write the memo for students. So the memo is not directed to students. So try to not copy the memo as students. Rather, learn from perhaps confirming that the answer is correct. Sometimes the memo is just as elaborate as you would wish as a student, but sometimes it's not. So it takes a mathematics teacher with a clear understanding to then decipher what's cooking in there and be able to transmit all of that back to the student in a manner that the student can understand. So this way of doing things, guys, is the correct way. Do not write answers like the memo does sometimes for this particular question, 8.1. If an instruction is very clear, an answer only is a dangerous move, okay? Once the question says calculate, please ensure that you show a calculation. Okay, there's our stuff. There's our answer there. And we did show a calculation. Yeah, of course, I kind of jumped the division, but I mean, it's almost obvious. But hey. Let me practice what I preach. So we know that DBC, bastard. DBC is going to be 96 degrees divided by 2. Therefore, please guys, adhere to instructions. It may look too easy and you think it's fine to just jump around. You will die. Some examiners may decide to be strict, and then you know what happens to you? What you did not expect. Right. It's not a good test that I'm eating here. Now ABD, looking for ABD, so it's the other angle. We know that angle ABD is equal to angle DBC. Why? These are angles subtended by equal chords. Given that AD is equal to DC. So therefore ABD is equal to 48 degrees as well. Now you sit down and ask yourselves, have we done a calculation here indirectly? Yes, I would want to freak out and say, why ask such questions in general and say calculate, when you know very well that some of the answers here are going to be more of determinations by inspection rather than a calculation. But the fact that we had made a calculation above, it somewhat justifies this one. Because to know DBC, since DBC is involved and it included a calculation, so we are safe. So this argument dies right at the door before it enters our minds. All right, so ons gaan aan hier somos, ons gaan aan man. Die werke is mooi. ADO, what is that? That is the angle. Don't know what is the angle in Afrikaans. ADO, what is ADO now? Is this one, is this one. Dangerous stuff there. Okay, so ADO is going to cause us a few issues now. But if we look at ADO is made up of something that is very You see that, friend? Plus this friend as a whole should give us 1/8, ne? Those are opposite angles of a cyclic quad. This is with the appreciation that this is a cyclic quadrilateral. Why? Because all its vertices kiss the circumference of the circle. You see, Mos, it's like this. So So we can see that, we've got a cyclic quadrilateral, and since we've got this entire angle B, we are able to find the entire ADC. But now, from this mini triangle, it's an isosceles triangle, so we've got 96, we'll have one of these values. In fact, we're interested in that. So if we take the entire angle and subtract that smaller one, it gives us the one in question. So this one is a nice one. As one can see, it's 5 marks because it's going to be a bit of a rough ride. So how we're going to do this, I would prefer to start with the cyclic quad. I know that angle ADC is equal to angle ABC. You lie? But we want the product, the sum. ABC, we should get 180 degrees. These are the opposite cyclic quad. We can name it ABCD. Easy. So this implies that ADC plus, now ABC is made up of two angles that are equal. So this is as good as 2 times 48 degrees equals 180. So therefore angle ADC is going to be the difference thereof. So 180 degrees minus 2 times 48 degrees gives us 84. Does it make sense? Yeah. To some extent it does, but I don't like it. That angle is obtuse by the diagram. You see, diagrams that don't fully represent what we want. This is less than 90 according to the diagram, and that's not quite representative. Then it means these values were thumb-sucked. Damn it, man. You're not supposed to do this, you see. Anyway, it is what it is, guys. 84 degrees. What can I do? It is giving me the vibes. So you see, this is where I get angry at the examiners, because they should not thumb-suck the values. There's protractors, man. Whatever drawing has been made must be measured accordingly. Then at least we should get an approximate answer. Something that is representative of what we see. Otherwise, why should we see something that's not exactly what we see? Gone are the days of our metric here, where diagrams would totally be a disastrous look and not look like what we are looking for, you see. That was just the essence of higher grade, accepting things even when they don't look the way that they seem to be. Maybe it's good, maybe it's bad, I don't know. I'm just enjoying my custard, guys. Don't cry. What is this one doing now? Right, let's do this nicely, guys. So what are we doing next? I'm gonna say, however, in triangle doc, that is memos, yamos. Let's see there, what is this doc thing here? We know that OD is equal to OC. These are ready, right? So what does this imply? This implies that angle ODC is equal to angle OCD, obsessive compulsive disorder. I have a little bit of that, right? These are angles opposite equal sides. in a triangle. So we've already stated which triangle we're working in. So we want the size. So this implies too that essentially ODC plus OCD plus DOC, the dotella is equal to 180 degrees. Now what is this sum? Alright, so guys, a reason must come when it has to come. Doesn't matter what marks there are, if there's a reason to be put. Now we're looking for angle ODC, so we can just say 2 times ODC plus 96 degrees is equal to 180. Therefore, ODC is going to be 180 degrees minus 96, all divided by 2, which is, let's see, 180 minus 96 divided by 2, we get 42 degrees. So we can say then, see, we answered the question after all the detours that we had to take. We see now that this ADO plus ODC gives us ADC. It's obvious, it's just there on the sketch. So ADO is what we want, plus this one we got 42 degrees. This is equal to 8. What did we get there again? 84. So we know that essentially ADO, the elephant park in Port Elizabeth. Is it Port Elizabeth or is it Uitenhage? Is it Uitenhage? What is that place called? ADO is ADO, man. ADO is ADO there. So ADO is just 42 degrees. It's telling us that here, it's telling us that this line here, DO bisects ADO. Okay, by the look of things, it's not too outrageous. We can accept the answer. Okay, although the angle looks obtuse, which is my only, criticism of it. See guys, systematic approach. We know where to begin, we know where to go next and why. Nice and easy. So for me, this statement is a powerful statement together with its reason and that intermediate answer. Essentially, this one is key and that one is key. So we've got how many marks? 4. Now we can decide. I think this one is more important than the rest. Then we've got one nice 5 marks there. We move on to 8.2. Excuse me guys. Yeah, 8.2 says in the diagram, O is the center of the circle. P, R, S, and T are points on the circle. This is what we call concyclic points. So once we hear about concyclic points, we need to think about angles in the same segment or a cyclic quadrilateral. So those are the things. Right. Now triangle RTS is drawn. Now what does that mean? Triangle RTS, it means this is a straight line, because a triangle has straight lines. So this is a straight line. This is a straight line. That is a straight line. If we are told this is a triangle. Right, and therefore, what does it make? ROT a diameter, and the diameter subtends a right angle at circumference. Nice and easy. And we know that the radii are always, okay, that's not a radius. got me going. All right, so there's more. We are told that OK bisects PR. So if this is the chord, is the line from center to the midpoint of chord, it means this is 90 degrees too. Right, now we're told O1 is 146 and T is 35 degrees. So those are indicated, not a problem. So we need to calculate the size of PRS. So we want this angle. Providing reasons. Okay. So how are we going to handle that? Okay, guys. So this is easy. We're going to use this angle. We can use this triangle to get that angle. And the other one, we're going to use that little small one over there. But let's choose another color. Let's choose another color there. We're going to use that little small angle there. Because now there's this triangle that we can use. You see this one. That angle we are given is the exterior angle of that triangle. You see? So if it is the exterior, and yet here we've got 3 angles, so there's a lot. These 7 marks are coming from saying this is 90 degrees and coming from saying that is 90 degrees. Then the others coming from R1, and then it's coming from R2. And the answer is finished, done, and dusted. So wherever we start, we are good to go. So we're going to say in triangle OKR. Ne? What do we know? We know that this angle OKR is 90 degrees. Why? This is the line from center to midpoint of chord. Essentially is perpendicular to chord. Powerful stuff. We can say then, not then, we can say also. We understand that essentially R1 plus OKR should be equal to 146 degrees. This is the exterior angle of a triangle. We're still talking about this one, which implies that R1 plus 90 degrees is equal to 146. Therefore, angle R1 is going to be 146 minus 90, which gives us 56 degrees. Okay. Here we can jump again and say in triangle. In triangle, RST. What's going on in there? We know that angle TSR is 90 degrees. Why? Angle in a semi-circle. All right. Okay, all right. We can say also, we know that TSR plus R2 plus that one. Can't tell you sigma wamefuna unipambanisa. Sum of 3 angles of a triangle. Now this means TSR is 90 degrees plus R2, that's what we want. This is 35 equals 180 degrees. So this implies that we've got R2 equals 180 degrees minus the sum of 90 degrees plus 35 degrees. Therefore, this is the one 180 minus the sum of 90 plus 35 is 55 degrees. We can say then we understand that PRS is going to be equal to R2. This is just what we see there. This implies that the cap must be there, guys. PRS is equal to R1, we got 56 degrees plus 55 degrees. Therefore, PRS is, okay, folks, we've done it, is 111. 111 degrees is done, is dusted, is finished. It's clear writing. Now, folks, what are we doing? The statement and the reason is interesting. And that statement and reason is also interesting. And hoying this one, 3 marks. That statement and the reason, very important. Heban, the marks are finished. Nieman, we need to drop something. Something must be dropped because the final mark is for the final answer. So, we're getting 7 marks, most. Yeah, that one is good. So we've got 1, 2, 3, 4, 5, 6. But there's a statement here, I feel the statement and the reason is more strong to get 2 marks because, it is what it is. So, folks, I'm on Scandi now. Do not do it. So, this is 16 marks that are very easy, folks. Big marks that are coming out of very simple questions. Folks, I'm going to skip doing the proof of similarity. It's gonna waste our time. You should know what to do there. I'm interested in answering the questions that are perhaps something to consider. So let's do question 9. Right? And then I'm gonna say 9.1. This is all textbook, guys. It's in there. There's no single math textbook that doesn't have it. So students, do your part, please. In the diagram below, AB is a tangent to the circle at R. Okay? So what do we say? We know that if AB is a tangent, we know that this angle is between the tangent and the chord. So it's going to be equal to the angle subtended by the chord at circumference. So that 10 chord theorem there. Now, C and D are points on the circle. Okay. But now we don't see C there. We just see D. So it means C is here, because that's the only other point that we can see. But we are not done. We are told here, what if C is this point? Yeah, it's possible. Anyway, let's see. Triangle RCB. RCB. As we can see, there's no RCB because there's no chord here given. So if there's no chord, therefore C cannot be there. Alright? So it means we are fine here. So triangle RCB is this one. Is this one? Is this one? Right. And RCD. Okay. Okay, so those are the two triangles are drawn. G is a point on chord CD. Already, if this is the chord, so this is good. We can see that. Such that AG is parallel to RC. So that angle is equal to that angle. These are corresponding angles. Right. Okay, chord RD and AG intersected N, so that's not a problem. So we can already see some proportionality theorem starting to show up. So let's quickly get to this question. 9.2.1, we need to prove that D and G. So this is the triangle, that it is similar to triangle ANR. So those are the two triangles that we are comparing, okay? Right, we can already see that angle was equal to that 10 chord and then equal to that. So this is good, but the good thing is that we also have vertically opposite angles here. This angle is equal to that. So once you prove two sets, similarity is finished, done and dusted. So we're going to say in triangle DNG and triangle ANR, we know that essentially N2 from DNG is equal to N1. These are vertically opposite. Vert opposite angles. Right, we say also, we know that, hold it. We know that angle NGD is equal to angle RCD. These are corresponding angles with essentially AG parallel to RC. Okay, and we've got a but. Why, sir? Yes, we know why. We know that RCD is equal to angle ARN. Why? Because this is the 10 chord theorem. So we make a conclusion that therefore, essentially, this NGD is equal to ARN. Now once we prove two sets, guys, we know that therefore triangle DNG is similar to triangle ANR. Angle. We don't need the third pair, it's automatic. Yeah. So it's pointless to mention the obvious, isn't it? 1 mark, 2 mark, that one, the final mark, you see? Thank you. Is the 5 marks as clear dichotis? Yeah. We are moving like a speed of light in a vacuum. BRC is equal to A. Okay, it's long and clock 10 days. BRC. Let's see, where is it? BRC. This one, guys, it's a giveaway. You see, most this one and that one, those are corresponding angles too. So we know that, okay, we understand that BRC is indeed equal to angle A. Why? These are all corresponding angles. with essentially BC. No. It's AG parallel to RC. So it looks like 2 marks for just that simple thing. Anyway, guys, we can see this was not a very difficult question, but rather one that needed a student to be brave and to look at it in the face. Okay, we are almost done backwards. So we're doing question 10. Usually there's going to be some complexity there. Buckle up. We might have some issues, but hey, this paper has been very fair. Okay, let's see. In the diagram below, PNRS is a cyclic quadrilateral. Where is it? So there is our cyclic quadrilateral. Now RS and NP are produced. Once we hear that word, it means we've created straight lines. Okay, they are produced to meet at K. Cool. NM meets SR produced at M. Again, that's the story. Chord PR is drawn. Right. You see that chord. KS equals SR equals RM. So that is also indicated. KM is 18 units. So that 18 units. So what does this make these others? This one is going to be 6 units, as well as this one, as well as that one, because it's just going to be 18 divided by 3. Okay, cool. Right, and then we are told that KP is A units and PN is 2 times A units. Right. Now let's hit this thing running. 10.1. 10.1.1 says we need to prove with reasons that PS is parallel to NM. Okay. So obviously proportionality theorem here is the only way we can say anything, because nothing else makes any sense, is it? Yeah. So we need to pick a triangle that's going to give us what we want. And we can clearly see that, okay, if we say in triangle KMN, what do we see there? We will essentially appreciate that when KS over SM is going to be 6 divided by 12. So that goes, and this gives us a half. Right? You can say also we know that KP over PN, this is going to be A over 2A. Again, that magic takes place, so we get a half. So this concludes that KS over SM is basically KP over PN. Now we know that in a triangle, when we've got a line that cuts the 2 opposite sides in the same proportion, that very same line, which is in this case SP, it must be parallel to the third side. So we can make the conclusion that, therefore, we can make a conclusion that PS is parallel to NM. What are we going to say here? You can just say, well, I don't know, guys. I would say converse of prop theorem. Makes life a lot easier sometimes to know how to remember. Once something is a theorem, we can use a converse. But if it is not a theorem, things like axioms and corollaries, we just have to state exactly what makes those meaningful. Again, folks, you would be fooled by these 2 marks and think it's just an easy job. It's not, okay? it's truly not. The last statement with the reason is important, but these two get the 1 mark. But we need to see both of them, all right? We want both of them. Right, 10.2, no. 10.1.2 says we need to prove that Pn is a tangent to a circle through R, N, and through R, N, and M at N. Okay, cool. So that is what is trying to have us prove what's cooking. Now what are we proving here again? Pn. So if this is to be a tangent, it means we need to prove that this angle is equal to that angle. Yeah? So that's exactly what we are supposed to prove. Okay, alright, okay. Okay. Just a moment. Alright guys, so let's move nicely. So we need to prove that those two angles are equal. So how do we do it? First of all, we have made a declaration of independence that those two lines were parallel. So that angle is equal to that angle. Ne? Those are corresponding angles with those lines parallel. But that same angle is equal to this angle. Why? This is the exterior angle of this cyclic quad. So yes, indeed, those two are then equal. So we can easily say, well, we understand that angle RNP or PNR is equal to angle PSK. This is the exterior angle of a cyclic quad, and of course we only have one quad here that we call the cyclic quad. Okay, now what can we say? We can say also we know that angle M is equal to angle PSK. These are corresponding angles with now PS parallel to NM, as we proved it above. So we can make a conclusion that this means PNR is equal to angle M. Therefore, we can say PN is a tangent to a circle passing through R and M at N. Why? This is the converse. 10 chord theorem. Right guys, my writing is dying and I'm under pressure now because I actually should be at work right now. But then I'm gonna delay it a bit till we are done here. Anyway guys, so this is not bad. Statement, reason, quite important. Statement, reason, quite important. That one is important, but I do think the statement and the reason, we can give it 2 marks. 1 mark for the statement, 1 mark for the reason. The rest is easy. But maybe let's not be silly. This conclusion is very important to highlight before we can make our conclusion. All right. Easy stuff, guys. Easy stuff. So we've got 10.1.3. It says we need to prove this ratio is a quarter of A. Okay? Yeah, now you can almost tell that we have a problem. Okay? Let's see. NM. Where is NM? NM is this one. Okay, and what are we looking for? NR. Yebo. NR is that one. Okay. So this is to be a quarter of A. So A means it's this side included. So how do we get there? If I look at NM, this is the side of the big triangle. NR is the side of this triangle as well. Are those triangles similar? Yes, they share this angle. And we just proved that this angle is equal to that, so these are similar. Okay, so it looks like we can use them. Is it possible? But of course, before we use them, we need to use similarity. Ne? So let me see. If we try to use similarity, NM is going to be opposite that angle. And opposite that angle in the other one is NR. Okay, that's cool. And then what are we going to say? Going to have to choose the sides that are corresponding. It's going to be that side as a whole. So that's going to be like 18. Okay. And over, this is going to be 3A. So 18 over 3A is not going to give us what we want, because it's not going to give us what we want. So it's not as simple as it looks. Yeah, ne? Perhaps I'm making an error. No, I'm making an error. Yeah, it's the correct one. Is the correct one. But what I may choose is to use this side instead. Actually, I was wrong in what I was doing. I was totally wrong. Yeah, I think that similarity will take us home. Let's see. In triangle, let's say KMN and triangle KNR. Don't really care about how I name them anyway. So what do we know? We know that angle K is common. Right? 2, we just proved that KMN, we proved angle M is equal to angle. What did we call that angle? PNR, yes. We proved it above. So if we prove 2 pairs, guys, we don't care about the third. Therefore, triangle KMN is similar to triangle KNR. The reason is angle. Okay. The third pair is immaterial. Now let's play with the ratios. we want mn, so we can say therefore mn over, now mn is opposite k. K is opposite that side nr on the other triangle, so this is nr equals. Now what I'm going to do, I'm going to choose this side. This is going to be 3a. Let's start by writing things. Say kn over. Now kn is opposite this angle on the other one, and then that angle is equal to that. The side opposite is kr. So we can just say similar triangles. I see that this reason is very easy. Perhaps we can say this implies, which also implies that mn over nr is kn is 3a divided by kr is just 12. Yeah. Therefore, mn over nr, so all we know is that it goes once, it goes 4 times. So this is indeed a quarter of a. So usually it can be hard, it can be easy, whatever, guys. Get it done, okay? There's always a way of doing things. So I think the similarity is important. Writing this one is important. Substitutions is important. And probably restating those two, yeah, you know. Anyway, guys, once we've done our job, everything is good, okay? Once our job is done, everything is good. So let's finish up this thing, guys. So we've got 10.2 here. Now 10.2 says, it is further given that triangle PNR, okay, where is PNR? Okay, there's the triangle PNR is similar to triangle NMR. Okay. So basically we're saying those two triangles are similar. Okay. We only know two angles that are equal, this one and that one. Now it says we need to determine the length of NM in terms of A. Yewena. Funa uthini ngo? Looks like we're gonna have a bit of a problem. Because if they are just similar, I think this is where what I don't care about maybe applies, guys, the frog face thing. But remember, don't get caught pens down. So we are saying this business P from the other triangle, this is this angle, should be equal to angle N, okay? And then kodwa la frog face yenu yenziwa kanjani kanini? Ingathi ayizoba ila frog face ke le. Kodwa nichuna kanjani la khotes? How is that thing working? But all I know is that angle M is N on the other one. So this one is good. Like that. Yeah, guys, it looks like it, because as long as this one matched, so I'm sure the naming here is somewhat important. I guess, the frog face thing, as much as I'm against in a way, but it's a standard way, of course, because here there's no other justification that we can put forward except to just use the frog face. And of course it means these ones are also going to be equal. I don't know how to get that frog face anyway. As you can see, I'm not the best. Ingabe ngamehlo wesele khona lapho. So I suppose, guys, we're gonna have to just say that if this is the case, because all we're interested in is NM. Now NM is opposite that angle. So it means this angle is going to be equal to angle R. Okay? Because these ones are already equal. These ones must be equal according to how this is named. Risky as it may be, we don't have a choice. There's not enough information that we can use here. And then it would mean this one is equal to that one. I don't see any other way of naming this. Okay? Yeah, so this is what we would have to say, you know. So which angles are we going to use? Maybe we need to use the angles that we need. For this business, NM is opposite that angle. And it's going to be over that. Okay, but now we need to do this in terms of A. So we need to play a bit of a cautious thingies there. We need to be a bit cautious, I'm supposing. But we already know that from the above, I think we need to also think about the above, because sometimes these questions are hiding the fact that they have relations with what we have done. So there we know already NR in terms of A, so I think we're going to win. I think we're going to win. We're going to say here, the two things that we need is to name the other angles that we did not know. So we can say this means from the other one, we can say N R, P and R. Of course, we can start with the one in P. It means P is going to be equal to RNM. These are corresponding angles in similar triangles. You can say likewise, we want PRN and PRN is equal to PRN is going to be equal to NRM. Same. Corresponding angles in similar triangles. Okay? Good stuff. Nice. So that is what we needed. This question was a tricky one. I think it's higher grade, although it's too simple to figure out, but it's not there. Okay, we can say this implies, we can even say then, we know that NM over, now NM is opposite that angle, right? That angle is equal to this angle. Then the side opposite that is PN. Should be equal to NR. Can write it nicely. Or we can even choose the other one. RM is 6 units. Why not choose RM? Yeah. Why not RM? Anyway, if I choose NR, that one is going to give me PR, which I don't have. So I must avoid what I don't have. Okay, so this means I must choose RM. Over. Now, RM is opposite this angle. That angle is equal to that, and that is opposite RN. Right. Yeah. So we can just say similar triangles. Again, proportional sides of similar triangles. This means NM over PN is 2A equals RM, we don't know, over Rn is 6 units, we're told. Okay, so we've got a but. We know that Mn over Nr was a quarter of A. So what does this mean? It means Nr is going to be 4 times Nm over 4 times Nm over A. Okay, let's just try and see what happens. So this implies that Nm over 2A is, this is going to be 4Nm over, this one is already defeating us now. I'm not happy. What a good plan. And it's just 3 marks perfect. And what is this now? What? Because Nm is going to end up going away. You see, that's just my worry now. Anyway, let's just go on. Maths is maths, guys. There's a way of dealing with issues. So this is divided by 6. Sometimes you just need to play the gymnastics nice and easy. So this is Nm over 2A equals 4. This is just basically 4Nm over 6A, essentially. Now these are like terms. You can bring this thing to the other side. See what happens. I got it's not gonna work, guys. So fun portrait walashwa. Hey, haibo, don't go. Haibo guys. Just long as I have no spanner. Aye. Okay, you know what I'm thinking now? What I'm thinking now is to express Nm in terms of Nr. Ne? And if we can do that, and then we solve for Nr in terms of A, so then we can be good. Yeah. Nr opposite that equal to that. Okay, let's use this one. Nr is equal to that over 6, yeah? And then we try to but you see the PR, I I don't want PR. It's gonna cause us problems. PR is not good. Oh, guys, these last 3 marks. It is a Sunday. We were just there and it just slipped away. Okay, guys. I don't know what to think now. I don't know what to think. Because we were just there. We were just there. I'm not sure what needs to be done now here. I told you, it looks easy, but it's not so easy after all, is it? Okay, let's just take it back a bit. I think we kind of rushed and it's not working out. So it's not really doing the things. Yeah, it's not gonna work, this one. It looked easy, but it wasn't so easy after all. Okay, let's try again. You can say then okay, let's try again. Say then NR over, from this one it's gonna be over that side, RM is gonna be equal to if I use this side, it forces me to NM, but I don't want NM to I. It's not gonna help. Okay. Okay, let's see. This is gonna be, I'm thinking now, but it's not happening. It's not happening. It's really not happening, eh? Why is it not happening? Why is it not happening, man? Oh, these last questions are like this, guys. It just cracks your brain, eh? It just does. RM. Okay, let's play. So we said NR, in terms of that is equal to that RM. Okay, cool. Now the next one, we want this side PN over, that angle is going to be equal to that angle, and the side opposite is going to be that NM. But you see, my challenge here is not coming together though. NR over NR over, okay, let's see, NR over RM is 6 is equal to 2A over NM. Okay. So what are we gonna do now, guys? We are just there, but we are stuck. We are just there. What about the proportionality theorem? Would it help us in any way? Doesn't look like it either. Because I'm looking at that proportionality theorem here, but it doesn't seem to give us much. Hi guys, nansi into ngoku isenza umhlola. I could. Now this thing is wasting my time. Yeah, boy, I think I'll go kokumo. Damn it. Heaven. The mathematics is mathematicking now. I don't know, guys. Something is not adding up, man. I'm not quite happy with this thing, you see. I get a visual. I don't know, guys. Vietnamese. But I'm thinking, but why not pull me, guys? Something is not adding up. If we say NR is for, guys, we can say but, I don't know, but it's not coming. One way, we know that NR, okay, maybe let's write as it is, MN over NR is equal to a quarter of A. So therefore NR, I think we need to eliminate NR, but I don't know why we're not winning. It's gonna be 4 times mn over a, right, which implies that we're gonna have 4mn over the a multiplies the 6, it's gonna be 6a, right, equals 2a over mn. Okay, yeah, I think this way, this alignment looks right, because if we can just do the things like that, we get ourselves mn squared times 4 equals 12a squared. See, we then divide by 4, so it means mn squared is going to be equal to 3a squared. Therefore mn is going to be the square root of 3 times a. I think that's it. I think that is it. So it looks like we just needed to structure our things. You know, sometimes, hey, but these questions, it's just 3 marks. So much work. Yeah. Okay. That looks fine. That looks fine. Again, guys, if this is in any way wrong, you will check the official memo. I don't have time now, guys. I'm already late, so I need to get to work now. So what are we gonna say for these 3 marks? Maybe to get here is important. This is important. And the rest is our own problem, it seems. Anyway, guys, this could have been a very challenging 13 marks towards the end. I mean, it looked easy. We were cruising. But now something happened, which I don't know what it is. All of a sudden, we were struggling. So this could be our 150 marks, guys. If there's no mistakes, please double check this last part. Perhaps to check the formal marking guidelines and gather some thoughts there. I'm not too sure if I'm doing the right thing, but it looks okay so far. I mean, I don't know what happened. Maybe I mishandled the ratios the first time around, or I twisted them, because sometimes it's all about how to align things the right way. If we align them the right way, we always win. But if we don't align them properly, we run into problems. Anyway, guys, this is it. I hope it was a good video for those who want to learn. And of course, Lucia, if I'm pronouncing your name correctly, I hope you also got your answers that you probably were looking for. As you can see, I also got a bit of a struggle as well. But a struggle means a learning experience. Otherwise, guys, I'll see you again next time. Goodbye.